हाँ हाँ उन्हीं ऊपर सुन. हेलो हेलो हेलो.
Is it okay? Okay. But I speak very loudly, so even if I don't need this actually. Acha, they are recording. Nice, interesting. So, but like you know about quantum mechanics, classical mechanics. Can I assume that little bit? I'm not gonna go in details of that, but like, so I will give you applications of machine learning in physics. But so it will be more application oriented, like where we use it, right? And then I will move towards a field which I come from, which is experimental high energy physics, and I'll talk a lot about that and then move towards more applications in that area. So it will be not too technical, hand wavy, but at least want to give you like some output out of it, like you follow something which I am talking. So that's why I'm trying to set a stage here, like understanding, like I don't want to bore you. That is not my aim at all. I want to be at least little bit more interactive. Do you need this? Huh?
Yes, your voice is audible.
Should I? He is. Okay. So do you want both to be here? Huh? This also? So many things. Just the record. Okay.
Live and this one is for
Is it okay? Okay. So whenever you tell me, I'll start. I don't know. Anmol, huh? Whenever you tell me, I'll start.
let me give you the brief intro about you.
Oh, sure. Go ahead. I have it also in my slides, but.
So, good morning everyone. Welcome you in the third day of the FDP on AI. So today's session will be taken care by the Dr. Bhavana Gomberman. Let me give you little intro about ma'am. Dr. Bhavana Gomber is an assistant professor at the School of Physics, University of Hyderabad, specializing in experimental high energy physics. She earned her PhD from the Saha Institute of Nuclear Physics, Kolkata, where her thesis focused on searches for large extra dimension using the CMS detector at CERNS LHC. She later worked as a postdoctoral research associate and visiting assistant professor at the University of Wisconsin-Madison, USA. Her research covers beyond standard model DSM researches, including SU, SY, and dark matters, Higgs measurements, and trigger electronic development for the CMS experiment. She has led and co-led major funded projects worth several crores, including India's participation in the CMS experiment and advanced electronic algorithm development. Dr. Gomber is a member of the CMS collaboration at CERN, holding leadership roles in physics analysis and trigger groups, and has contributed to cover over 650 referred publications. She is recipient of the Raoul Bose Memorial Award for Best Thesis in High Energy Physics and part of the CMS team recognized with the 2025 Breakthrough Prize in Fundamental Physics. So, welcome you, ma'am.
Thank you. So again, good morning. Here is my link in case you need to know some more information. So my bio he already spoke about, I don't have to go again, but my main research interest, CERN is CERN. It's a lab which is there in Geneva, Switzerland, which hosts many experiments, and university is part of this. I am part of this experiment. So I just want to highlight one thing here before we go deep into machine learning and physics. So I am part of School of Physics. There is a specific center called CASSIST, Center for Advanced Studies in Electronics, Science and Technology, where we do a lot of electronics related work, because in my experiment, physics, engineering, many things are there. So I also work on electronics part. I just want you to know about CASSIST, where I come from. And it has MTech courses which we offer, MTech in VLSI, microelectronics and VLSI. We also offer a PhD course, PhD Electronic Science and Engineering, since you are coming from the place where you will produce the students which will come to us. So I thought it's a nice place to advertise also ourselves. So in case you want to see, you can have a look at this poster, and the website of CASSIST is here with my thing, but you can see a lot more details, sir, in case you are interested. Sorry? Yeah. No, we take through JOSA counseling. So, and then earlier we used to have the entrance exam ourselves, but through GATE we take, and through all these basic national courses, we don't have our own entrance exam. We tried, but then university have different rules and regulations. So it's like through common entrance exam only we take students, yeah. We have 36 seats in collaboration. So it is AICT approved. We students also get funding of 12,000 per month. That's what I'm telling you. This is CASSIST is a separate entity. It is a department which only hosts this MTech. But it's a center associated with physics, because we do a lot of interdisciplinary research. Because these days, everything requires interdisciplinary research, right? Materials, like many other faculty works on materials development. So that requires both physics and electronics. We have a nanofabrication lab and all. If you're interested, I can talk more about that. Coming back to my, sorry. Sorry? Fee structure. If I remember correctly, I think it's around 50,000 per semester. Not a lot like other private universities offer. It's 50,000 per semester. So it's quite decent. And students get placed very well. You can see. So you can have a lot more information on this website. That's why I just put this website link. You can have a lot more details there. And there are many faculty who are working on many different fabrication, digital, like I also do a lot of digital stuff. VLSI processing, FPGAs, we do all that. But my field is very interdisciplinary, so I do both physics and electronics. That's why you can see why I'm standing here with the physics title. Because I'm mainly an experimental high energy physicist. Okay? So having said so, here's a disclaimer. In the whatever schedule they have given to you, there are so many topics, right? They wrote AI in everything. In physics, they covered everything. So it's impossible for a person standing here to cover all that. So I will touch base on each topic, but I will cover mostly like how we do machine learning and experimental high energy physics. And don't worry, I will tell you what is experimental high energy physics before even going there. So you will at least go back with some idea what is high energy physics. So before that, we can start about the other general topics and see where AI is being used, it's been implemented. So, astronomical image analysis. I believe in the last 2 days, somebody has come and told about what is AI, what is machine learning, what are the different ways, right, we can implement it. I will also cover a little bit in my slide, but not in very mathematical detail, but more like a logical reasoning detail. So, the first topic I want to cover here is astronomical image analysis. So what is astronomical image analysis is, you have all these stars, right? We have a sky. There is a lot of data which comes from there. And there is a lot of image analysis that can be done. So machine learning algorithms are basically increasing our ability to process this vast amount of data which is there. You can identify galaxies, stars, and exoplanets with like very speed and accuracy. So think if we didn't have machine learning, it's like you have a data. Those who are doing this kind of research, they have to process it. First of all, it's such a huge data, you have to store it somewhere. Then you have to analyze it, right? Storage part is still there, but analyzing capability becomes very, very fast when you use machine learning into that area. And then you can predict very easily. So that is one scope which is there. Then you can also classify the objects, right? You can, if you see a new object in a sky, so there one can classify it easily using the different techniques which machine learning provides. You can, so there is this gravitational lensing. This was a major discovery which happened recently in physics. I don't know if you are aware of it, but that could happen because what happens when you are discovering something new, it's like very few events, like 3 or 4 events in a billion or million of events. So you need to have a technique which is very, very accurate and proficient in finding such events. So that happened because of machine learning. And then a lot of analysis of galaxy structure which happens can take place using machine learning. Then particle physics at CERN, this is which I belong to. I will talk about it a lot more, but you can do a lot event classification, you can reduce a background, you can do measurements, but we'll come to it. Okay, material science revolution. So these days, discovering new materials, okay, earlier it was not that straightforward, right? Because you have to do a lot of simulation, you have to synthesize this, and then you have to see the properties, and then you can predict something new. Now with AI-driven methods, you can actually accelerate this discovery of the novel superconductors and quantum materials. So you can predict their properties even before synthesizing them. So where in the material science this can happen? First one is the structure prediction. You can propose new crystal structure. You can simulate and predict the property of this different behavior. You can also synthesize the optimization, meaning you have different parameters, right? You can optimize those parameters and then go for synthesize. Because otherwise how you would do? You will set some parameters and then you will synthesize. You don't know if it is the optimized one. So machine learning gives us a capability to optimize those parameters first and then go for synthesis, which will lead to even a better accuracy. And again, it saves a lot of time, I think. And then if you discover something new, it's like a discovery, right? Then this I found very interesting when I was reading for this talk. So energy system optimization. So one is this grid load prediction. So what happens? We have this time series forecasting models which will predict what is the demand of electricity in that area, right? So it will produce that load efficiently based on that. And then there will not be any blackout, right? So you're optimizing your generation by already analyzing the data which is available, and then you are making sure that all the regions get whatever they need in terms of energy. Renewable integration. So this is also very interesting. You know, we can produce electricity using solar, wind, and other power sources, right? So if we already know what is the prediction of a day in terms of a solar wind, right? So that day we will optimize the energy generation using solar wind. And the other day we will use based on the wind. So basically we can optimize and balance the different sources of energy and then based on the weather variability. Because today the weather is good for having the energy through the solar wind, right? Solar. So we will use that. So otherwise what happens? Machines are running for solar power generation, for wind, and also our other resources, but it's not optimized. With AI, now things are more optimized because you already can predict what is the weather condition. So based on that, you use your resources. Then distribution efficiency. So what happens is, so real-time algorithms will manage the power flow across the transmission lines. So what happens? There are algorithms which, when we say real-time meaning it is running at that moment. When we are taking something, the data is processed at that moment. And the real time it will tell you whether the transmission, the power requirement which is there is enough or not. And with the real-time data, you can monitor the power flow, and that basically help in reducing the losses. Because assume there is no real-time data, right? You have power management which is going through, and it will occur losses. But if you have a real-time algorithm which is sitting out there, then it will stop the flow. It will not let it run. So that way the AI is helping in many of the energy system optimization. Then the most important and the interesting fact which I liked was this climate modeling advances. So weather pattern prediction, this is like a very societal effect you can see, right? Every year we hear that there is a cyclone coming in Odisha, right? There is another thing happening somewhere. So now with the AI in picture which is involved, we can predict the weather. So we can do this cyclone tracking with the computer vision algorithms, which will already predict the storms in the space, and it can also predict which area will it fall in, which is called this landfall location. So what will you do? You can't stop cyclone, but you can at least evacuate the people who are there, right? So that will help us in the less, meaning catastrophe which happens or the situation. So we can improve, take a decision.
Sound decrease. People wants to decrease the sound.
I told you I speak loud. Am I not audible without this? I mean, I really speak loudly, so that's why you'll hear double of my voice.
You can ignore it.
Is it okay for everyone? Yeah. It's not required actually. Shall I continue?
Yes, sir.
Okay. So the cyclone tracking I mentioned, then weather pattern prediction. So basically, this deep learning models will forecast the extreme weather events, and it will basically lead to the accuracy. So what happens, if you remember, every day we can see our weather prediction. Is it going to rain or not? That is a normal thing. I also check. It's never right. At least 5 years or 6 years back, it says it's going to rain, never rains. But when I went to Switzerland, their weather prediction was brilliant. They even tell it will rain at 9:35 p.m. and it actually rains at 9:35 p.m. So I was very amazed with their modeling, because what it goes there, right? It all goes the modeling, right, of the weather conditions and everything. So they were already implementing those AI models into place, which India started doing now, and now our weather prediction is better. I don't know if you notice, right? If it tells, it happens, so which is very nice. So how that change happens? Because they employed AI, deep learning algorithms in their modeling. So this is all like very generic examples of how AI is helping in our daily life, right? Because this climate thing is very, very important. This cyclone tracking is extremely important, because we suffer a lot of loss, right? It's not only human, I mean in terms of infrastructure and all. So that is where AI is helping quite a bit. Then yeah, this is also quite interesting. So remote sensing application. So what does it mean? Government decides one day, how do? People go for survey, right? Land survey. And they say, oh, this area is not good, we can go for deforestation and all, right? So we can make buildings. But it takes time, right? And sometimes you might have heard a story of our nearby thing, right? Government even takes advantage of things. Forget AI, just they come and bulldoze your thing. So if I talk scientifically here, so in case we really want to see, like we have a land, right? Whether it is a good land, can we use it for urbanization? Does it require deforestation? The people have to go and do the survey, right? Which is a very time-consuming task. So now that is changed, because we have now this image acquisition, because we have satellites, right? Which are already capturing the data. So multispectral data meaning temporal and spatial. Spatial meaning space, temporal meaning with time, right? Because we don't only want spatial data, we also want to see how it is moving with time, right? So satellites capture both these data, then we process it using AI, and then algorithms can quantify whether deforestation is there, urbanization is there, resource depletion is there. So these things help us to take a decision, okay, and a scientific decision, not only by looking at a piece of land and say that, okay, deforestation is happening. You're looking at the entire picture of a land and then making a prediction using some scientific logic is there, not just 10 people deciding. The bribing is easy when 10 people go. With AI, that's not possible. So I think this is really wonderful. Okay, so having said so, I tried to cover a lot about the generic physics. Now I will focus on one particular field of physics, which is my expertise, which is high energy physics. So if you think I'm boring you, please interrupt me. I don't want to bore anyone. I always like to speak in a way that somebody at least listens to you, because as a teacher, I also attend. University teachers have to attend to refresher course. So I know it can be painful. So that's not my aim here. So the question is, why machine learning in high energy physics? Okay, so maybe these slides we should come later, because I think many of you might not know what is high energy physics. I am using words like what is standard model. So forget this, let's talk little bit interactive way, like everybody might know the structure of matter, right? What is the structure of matter? We all know there is a nucleus, there is an electron orbiting around it, very basic, right? We all studied in school. So in this structure of matter, now the question which high energy physics people ask, what is elementary? Elementary means a particle which you cannot divide further, okay, which is elementary. This you cannot break it further. So electron is one particle. What about nucleus? Nucleus is made of? Protons and neutrons, right? Great. So is there anything further within neutrons and protons? Very good. Thank you. You have saved me. So neutrons and protons are quarks. So till some point back we know this. So quarks are the fundamental particles, right? And then we have an electron, which is a fundamental particle. Now the question arises, which experimental high energy physicists try to find, can we go beyond that? Is there something beyond? Because it's not like someday we woke up and said, okay, quarks are elementary. There were experiments which were done, right? So I will walk you over like how we do those experiments. How do we figure out what is elementary? And high energy physics is, very fundamental science. It talks about who gives mass. What is it that gives mass to all the particles, right? Everything has a mass, you, me, trees, everything, right? But there must be something which gives mass to that. Then what are the particles which we know as of now? We know there are 4 forces, right? Electromagnetic interaction, strong interaction, gravitational, what am I missing? Weak interaction, right? Right? So all these interactions also exist in smaller scales. Now, knowing this information, let's move forward and see if I am able to make a connection, and then I will put machine learning into it. So then you will see how for basic discovery, okay, there is a basic discovery which happened in this field, which was Higgs boson discovery. I don't know if you know, this happened in 2012. It was the major discovery which happened in the entire world in physics. And then after that this gravitational lensing happened. So these two are the major discoveries that happened in physics area recently. And I'll at least try to cover this Higgs boson discovery which happened, okay. So why AI is important here is, what we want to do, we want to probe the standard model with the precision. I'll talk about what is this. And search for new particles. You said quarks, right? Electrons. So are there new particles like this? We can also find that. So sorry? So I will connect everything together. Just give me 5 minutes. Gluons are the mediators of strong interaction, okay? So what you need is, your signal is very rare and you have a huge background. So what you have to require is, identify the rare signal, okay, in an immense background. And the data which we collect, we have a machine which is called Large Hadron Collider machine at Geneva, Switzerland. It is very complex and high dimensional. So if we use the traditional analysis techniques, okay, they are not easy to extend to high dimension. So you have to use something called multivariate analysis. Have you heard this name in 2 days? Somebody came and spoke, right? Meaning you have, what happens, one dimensional is what? A car is moving with a velocity, right? It's one dimensional. But if you also include another parameter in there, right? What is the acceleration? And you want to tune those 2 parameters. It is 2 dimension. Similarly, if I add more parameters to it, it becomes multi-dimensional. So why the traditional things will not work? Because our data is very multi-dimensional. So AI really plays a major role here. And I'll show you how. So to identify this rare signal, actually what I'm talking about is like 10 events in like a million background events. So you will see even the plots, like how does it look. So you need to draw the decision boundaries. And machine learning algorithms are the universal approximators and can do this job well. So this has been used, you know, in machine learning has been used in the colliders area. So you can say high energy physics. LHC is the current experiment. Before that, there were many experiments. There was this large electron positron, 90s, this was there. Before that, there was an experiment in Fermi lab, Bell. There was an experiment which was, so it's not like this is started now. It's starting from 50s when we started discovering particles like this gamma rays, right? Which gamma rays were coming. How did we discover muon? Through cosmic rays, right? They were coming and then we had an experiment. There we found a muon. Those were very simple experiments. Now the techniques have improved, engineering has improved, and that has made us to such a big experiment which we are running right now. So I think this is all theory. Let me talk a little bit here. What is CERN, which he was telling? It's CERN, okay? So CERN is the lab for particle physics. It's the, at one time, only one accelerator can run because it's like a billion-dollar investment which goes in making such experiment. Single country cannot do it. China wanted to do it, but their government shut it down. Because they are rich people, right? USA could do it once, but now what we have running right now is this one, CERN. There is only one experiment. Many countries collaborate. You can see entire world is collaborating for this machine. India is here and we are also collaborating. We are associate member. There are 20 institutes from India which are collaborating. University is one. So you can see how many people it has. It hosts a lot of visitors. Students from university also goes there. Look at the budget, 1,000 million CHF. One CHF is 120 rupees. So we are talking a lot of money here. That's why it's not possible. India tried to build its own experiment. I don't know if you know INO. This neutrino observatory which was shut down because in Tamil Nadu, government politics, many things happened. We could never do it. But China went ahead from us. They did it and they did a lot of work. So it's not easy. Sometimes not only money, you need government support, you need people support, because people thought this will create something which will kill people. So scientifically that is not right, but people had such a weird assumptions about it that, and then government politics played into picture, so it really went very bad. Otherwise India could have really grown a lot in this field. Anyways, and by the way, this is the place where the World Wide Web, WWW, we use, right? This is the place that was born. Scientists in this lab has developed this WWW. So it is a big deal. This lab is a big deal. Many discoveries, many things have come. In cancer treatment, right? What do you use? You know those machines, right? These are accelerators. So the accelerator technology came from CERN. So what happens when we do physics in this such big experiments, we develop also technologies which are used in the other areas. So that is why doing high energy physics is not only physics, you are also doing a lot of benefit to the society. So if whenever you have time, just read about this radiotherapy, right? So what is used there is an accelerator, and that is the accelerator which we developed here in CERN, and that is the technology transferred to medical. So it's a lot of engineering, physics, everything goes in there in this CERN. So what are we trying to answer? What is the world made of? Who holds the world together? Where did we come from? Simple things we are trying to answer. So now accelerators. You must know, right, this de Broglie wavelength. Lambda is equal to h over p, right? We all know that. What does this tell you? P is what? Momentum. We can equate it to energy. So if a particle has a high energy, right? So okay, if a particle has a small energy, you will see high wavelength things, right? If a particle has a high energy, you can see smaller wavelength. What does it mean? If you have to see a substructure of a particle, right? How did we figure out that protons have quarks? You know this now, right? Protons, neutrons have quarks, using these techniques only. So, protons has quark because we could see the substructure, meaning proton is not elementary. We could see many other particles which were binding the proton, right? It was UUD. But then there are many other things. It's valence quarks, C quarks, all that stuff is there. So if you basically increase the energy of a particle which you are colliding or accelerating, you can see more inside it. That's what this small equation tells us. Meaning if you increase the energy of a particle and collide it, then you can see a lot more inside it. So that was the idea. This is a Large Hadron Collider. It's like Google showing. It's a 27-kilometer ring. It is at the border of Geneva and France. So what we do two beams of protons collide, and in a very tiny space, temperature is very high. It produces many particles. It basically takes you a stage which is like the beginning of the universe, which we call Big Bang, because you're colliding at very high energy. And see, when you collide something, you can also create new particles. E is equal to mc square, right? So you're putting a lot of energy. There are two things you can do. You will produce new particles, or you can go in the substructure of that particle, right? So that is what it does. So this is structure of matter. You know that, right? So now, as I was telling you, are there still smaller particles? Molecule, atom, electron, neutron, proton, quarks, right? This you all told me. But then, are there more smaller particles? And let's see, try to address this. These are the four forces of nature: electromagnetism, weak, strong force, and gravity. Gravity, which holds the planets. Strong force holds the nuclei. Weak force gives radioactivity. And electromagnetism is which gives the light, radio, and hold the atom together. This is something very basic, just to cover the thing. Now the main question, what is Standard Model? Just 1 second. So what is Standard Model? Since we know all these particles, what we did, we grouped them together. Okay. So we said quarks. You know about electrons, right? There are similar particles, muons and taus. These are all together called leptons. And these are neutrinos. So these are all fermions. Okay. Why fermions? Fermi, Dirac statistics, right? Spin half. So these particles follow that statistics. So bosons are what? We said there are four forces. One is weak interaction. So what happens? When two particles are interacting, they are interacting through a force. So when they are interacting through a force, something is mediating. There is a particle which is mediating. So for weak, it is Z and W boson, which are very heavy. For electromagnetism, when we say light, we say photon, right? We use this word. So this is a photon. And gluino, somebody was telling, right? This is G. This is the interactive particle for strong interaction. So entire all these things together forms a Standard Model. Now, these are the particles of Standard Model, right? Now the question was, but it doesn't cover what gives mass to these particles, okay? And there was a theory which was written back in 1950s, and that predicted that there has to be another particle which is called as Higgs boson. Higgs boson is responsible for giving mass to everything. And that is the major discovery which happened in 2012 and led to a Nobel Prize in Physics. So, we have some open questions in particle physics. What are the masses and properties of neutrinos? What is the nature of dark energy? What is dark matter? Just to give you one thing, whatever we see around us is matter. I hope all of you know, right? That is only 5% of the entire universe. We still don't know. Everything. Because the way they interact with the Higgs boson. So the interaction matters. How much they are interacting gives them a mass. So I have a very nice slide which will show you how that happens. Just hold on for a second. So what I was trying to say, whatever we see around us is matter, which is only 5%. There is still 95% we don't know. And there is a division called dark matter and dark energy. So we still don't know what is dark matter. That is what LHC is trying to pursue, which I also work on. Then are elementary particles fundamental? Is there anything more than quarks? What is the physics? So this is Standard Model, right? There is a Higgs boson, there are fermions, there are boson. Is there anything beyond Standard Model? So there are many other questions which we try to answer. Okay, yeah, now coming to you. Higgs boson. So Higgs field is present everywhere when everything else is quiet. Its quantum is massive, spin is 0. Particles move through this field and continuously interact with this field, okay? So which will slow them down and they will appear to have mass. More the interaction, heavier is the particle. Meaning like electron is interacting with Higgs boson. Electron mass is very small, 0.511 MeV, right? It means the interaction between electron and Higgs is very less. That is why it didn't get that much mass. So In collision experiment, we should be able to produce this Higgs boson, but we do not know what is the mass. That is what this experiment predicted in 12. So this is a,
It's okay. Then my question is, electron is not made up of Higgs boson.
no, we are not saying that. We are saying electrons, leptons are some particles, then Higgs boson is other particle, which is responsible for giving mass to everything else. And this Higgs boson is also massive. That theory predicted, the standard model predicted, because that's how we do, right? We have a theory which will predict something. And their masses is also small, except top quark. So everything, quarks, leptons, Z, W, photon, everything is interacting with Higgs boson, and Higgs boson is responsible for giving mass to all the particles depending on how strongly they are interacting with Higgs field. Okay, Higgs boson is like a Higgs field. There is a field, like you must have studied the EM field, right? Similarly, there is a Higgs field. So Higgs field is everywhere, and these particle interacts in the field. Look at this cartoon, it's nice. It's like there is a party going on, okay? It's like a Higgs field, okay? What happens? Some famous person comes in the party. What happens? We all crowd towards him, now, right? So this is happening. Famous person is coming, crowded. So what happened? He slowed down. So what he did? He acquired a mass because it interacted with the other people. Okay? So that's how simple is the story here. Higgs field is like a party. It's everywhere. Somebody entering. So what happens? Like even I start entering, right? I will start talking to one or two. So what they are telling is this interaction is giving them mass. Okay? Then more the interaction, more the mass. Okay? So Higgs field is responsible for giving mass to everything which is around us. If you remember, I don't know if you remember the news. News even said Higgs boson is a God particle in India. That happened in India. It was referred because what we know from our old culture, God gave us mass. God is responsible for whatever we are, right? And then scientifically, we say in physics, Higgs boson gave mass. So then they named it as God particle. So it was all everywhere in news. I mean, this became a big deal, and then the other side of the country, people was not happy that why you're correlating like this, but fine. Indian news did that. So I hope the concept is clear with this, right? So the more the particle will interact with the field, more the mass it will get. Photon doesn't interact. That is why photon is massless. Okay? So if we think in scientific logic, so what Higgs cannot do, so,
What are moving? They have some mass. That's some mass moving. That mass is zero. What are such mass? Then how will get the mass?
what photon? See, so that is not a real photon. There is something called, I don't know, real photon and virtual photon. Virtual photon can have mass. Real photon is massless. Virtual photon is what? Two electrons collided, produce a photon, then photon again made E plus E minus. So this photon, it's the time for which it was produced, it's very small. It is called a virtual photon. Somebody was saying, sorry. So that is what a virtual, that will have mass, but for a very short duration, because Heisenberg uncertainty principle has to be applicable. I hope, right? You know, delta E, delta T, right? So you can get mass for a very short interval of time. That is for a virtual photon, but the real photon has zero mass. Any other question? Okay. So what, now let's see logically, meaning scientifically. I told you very generic picture in terms of a party. So Higgs boson will be produced and can also will decay. So now here it tells you a nice way that Higgs cannot be produced through gluons, and it cannot decay to photons directly because gluons are massless and photons are massless. So Higgs cannot interact with something which is massless. Okay, because the whole idea is when something is interacting with Higgs, it should have mass, right? And if there are particles, like gluons have zero mass, photons have zero mass, real photons let's say, so Higgs cannot interact. So there will be something else which will be there in here, there will be something else which will be here, which will make this reaction possible. So Higgs will not directly interact with photon, but Higgs will interact with photon through some other loop, some other particle let's say. Okay, that is going a lot into particle physics, so I don't want to do that, but assume there is another particle which has a mass, Higgs will first interact with that and that will decay to photons. Okay, so that's why it will happen. So these are really details, but we don't know the mass of the Higgs, okay? This is theory prediction, the cross section. What is the cross section for different processes as a function of mass? Because when you don't know the mass of Higgs, what you will do? You will look into the entire range, right? It can be anywhere. That's what we did. So we don't know, but we know these theory predictions. So what we did, this is very technical, I will not go there. So we have different processes in which Higgs can be formed. Higgs can come from WW, BB, tau tau. I mean, it's fine, you can ignore all this. So let's come to the main thing. So this is a theory. We know Higgs exists, theory predicts, but we do not know in the experiment. So we want to look for this particle. When this machine was developed, the aim was to look for this particle. What you need accelerator, you need detector, you need computing, and you need a collaborative science, meaning the entire world comes into one place and work on this problem, right? Because only it is such a large scale problem, 10, 15 people cannot do that. So that is why we have a collaboration of thousands of people together, right? Working on it. So accelerator is what? This Large Hadron Collider is an accelerator. It collides particles. Now particle is collided, you have to detect it. I hope you know this calorimeters, like which measures the energy, like these crystals are there, lead tungstate crystals, right? If a particle hits, you can measure that energy. Okay, I mean, so that those are called detectors, meaning you will record the result of this collision. You have to record it somewhere. There has to be a camera, no? We should take photo, whatever happens. So think of it, camera is like a detector. Okay, it's a big camera. So as I said, it's a big ring. So TeV, what is the unit? Electron volt, I hope everybody know, right? Energy unit. TeV is 10 power 12. Okay, terahertz, tera electron volt. So we are colliding particles at such a high energy. Okay, then of course it will produce new particles. It will produce new particles, and you can also go inside because lambda is equal to h over p. You are increasing the energy, so you can see the substructure, right? So that is possible. So main target was origin of mass. Higgs boson was the main target when we started this machine in 2009. Okay, so in 2012 we discovered it. After that, many other things are happening. So some facts, it is colder than the empty space in the universe. It's a very big machine. It is emptiest place in our solar system. It is hotter than the sun, okay? So this, see, physics is once we get data, we do physics. This is all engineering. Making this machine is all engineering. That is where there are a lot of engineers who work in this field, okay? And it's really challenging, and we developed the superconductors, meaning this experiment needed a superconductor with 3.8 Tesla. There was no superconductor which existed before this experiment started. So engineering, capabilities improved. So that is why this field really is a nice fusion of engineers, physicists, and now, of course, data scientists, because you have a huge data which you have to analyze. So there are different experiments. CMS is one where India is involved in CMS, and ALICE, okay? I am involved in CMS. So this is a detector. This is the experiment, CMS experiment. It has basically different technologies, because when you're colliding particles, you're getting a lot of particles, right? You have to detect them. So I don't know if you guys know, like electrons, right? Electrons everybody knows, right? So when electron interacts with the matter, right, it produces more particles. So we need to have a technology which will take that thing. So we have a technology which is lead tungstate material. So electron is interacting with the lead tungstate material and producing more events which we record in the detector. So there is a lot going on there. So this is a collaboration. You can see one photo happened. So now this is important. So the data challenge. So what we are producing is 15 million gigabytes of data each year, which is 20 million CDs. So think, this much data we are producing every year. We are running from 2009. What do? You have to store this data because our background is huge, our signal is small. So we have to analyze the entire data. So we have this grid computing. Grid computing is tier 2s, meaning we have these big servers, okay, in the entire world. One is in TFR in India. It's a big grid. Then we have many in US, many in Europe. We save the data there. And we analyze everything together. Like I sitting here in University of Hyderabad can look at the data which is saved in Wisconsin. We all have accounts on cluster. That is why it's a collaborative research. So I can analyze sitting here any data. I will connect to that cluster. in Wisconsin and can take data from anywhere else. That is called grid computing. Okay, it is connected in a grid. So our entire data of LHC is connected in a grid which can be accessed by anyone, anywhere. AAA, anytime, anywhere, any place. Yeah, that's the technology which has been developed. So this I leave. So yeah. So what we're trying to do is, you have needle in the haystack problem, meaning this is a haystack, you have to find a needle. That's how it is. You have such a big data, you have to find a small needle in it. So that's the computing challenge now. That is where machine learning and data analysis comes into picture. So we discovered it in 2012. It was a big event in CERN and Australia. It was followed live around the world. So what we see, so you see here, now this is important. So this is data, black points are data, okay? This red is a background. Forget how we did that, okay? Forget the technique, but look at it here. This is a small thing. How many events you see? 100. 100 events between this range, we see a peak. And that is where the Higgs has been discovered. It's around 125 GeV. Similarly, in the another channel, around the same place. Similarly here. Similarly here. So in two different channels, we found it at exactly the same place. That is how, whenever a discovery happened in any physics research, okay, it is a lot of statistical analysis. You have to look at the data, you have to analyze a lot of things, okay. So when we found this in CMS experiment and ATLAS experiment, two experiments found the same thing at the same place. That is how it was told it is a discovery. And there's a lot more statistical analysis goes into there, but it's not easy. You see some peak, right? It's not easy to say it's Higgs, right? But you saw it in different channels and different experiments. So two experiments confirm the same thing. And there's a lot of data analysis techniques which happened here, which brings me to the topic of your research. So it's a battle, we are saying, it's a Higgs boson, it's a battle. So what we use, multivariate analysis, aka machine learning, we use the statistical test, and of course many other things of the detector matters. So now, I hope you know this, but I will walk little slowly so that you understand this. So what is machine learning? Machine learning is a statistical algorithm that can learn from data and generalize to unseen data. That is the important thing, meaning you have so much data, you learn something, like we are humans, we are learning, right, every day. And then we also predict, right, in some sense, oh, tomorrow this will happen. May or may not be right. It's the same story. So we have a data, we learn from data, and then we predict on data which is not seen. That is the power, because if you predict on the data which you have seen, then it doesn't matter, right? So when it predicts on something which is unseen, that's where the power comes from. So what we do, there are three parts: supervised, unsupervised, reinforcement. I'll tell you in a very simpler way. So what is supervised learning? Supervised learning is, you have some data with inputs and the correct labels, meaning I know my emails, right? It is a spam or not. That I know for some part of my data. Now, I can do a training and then it can predict on a new data whether it is a correct email or a spam. Okay. So what you know is, you know input, you also know the correct label here. Then you can predict. The task is to predict. So it is classifying, right? This is called binary classification. Signature from detector, meaning there are different particles coming out, right? So it is multiple classification because it can be electron, it can be muon, it can be something else. So that is called multi-class classification. Now this is very interesting. You have a house for sale and you know the estimated value, right? Now you can train this and then what you predict is will be done using regression. I'll show you one example for that. But in supervised learning, the main thing is you are supervising it in the sense you have an input, but you also have a label to it. You have some data which has an input and also you know the label in the sense you know this is a correct email, this is a spam email. This is called labeling, right? Classifying it, like my email is classified into inbox, spam, junk, right? So this is label. I know this for some part of a data and then I categorize it for the new data, right? So this is called classification, which is binary classification. Then if you have more labels, then that is called multi-class classification. Then there is one more thing called regression. So did anyone taught about this? Right? You have heard this, it's not something new, right? Okay. But I don't know in how much details. Then there is something called unsupervised learning. Now there is no supervisor here. You have some unlabeled data. Data is there, okay? You don't know what is that data, but it is there. So it is a main point about unsupervised is unlabeled data. You have no idea about any labeling for that data. So you can learn any kind of pattern from data. So most important type is like list of news articles. So what you will do if the groups that cover the same topic. There are news articles about education. So you have clustered them into education. There are news articles about politics. You will cluster them into politics. There are news articles about entertainment. You will cluster them into entertainment. Okay. This is called clustering. Okay. Based on the common feature which you see in that data. Similarly, in my field, we have an energy deposit in cells. Now, audio recording. Okay. So you have some recording of the audio. Now, what you want to make, because audio recording again is a huge data. So what you do, you compress that. And how do you compress it? You reduce the file size. Okay, what is the output you want is, you want audio recording but with the reduced file size. That is called compression. So in unsupervised learning, what are the machine learning tasks? Either you will cluster or you will compress it. Whereas in the supervised learning, what you will do? You will do the classification mostly. Okay, I hope this is like a very simple way of saying it. In supervised learning, we will classify binary, multivariate, or we'll do regression. In unsupervised, you will do clustering or you will do compression. Clustering is you will group them into cluster. Compression means you will reduce the size of it. Okay, and this last part is also quite interesting. It is used in many places. Now there is something called reinforcement learning. So what is reinforcement? You learn by interaction with the environment, and this is also very powerful. So, see, these days you might have heard, right? In US, these cars are coming without these drivers, right? So how that is happening? That is happening because of this reinforcement learning. So what's happening is, you are using the real-time sensors at that moment. It interacts at that moment in the real time and then decide, right? Because what's happening when a car is going on, if it finds an obstacle, so there is a real-time sensor at that moment, right? It should stop. So, based on its interaction with the environment, it is stopping. That is where this is, I'm telling you very, in a hand-wavy way so that at least some feeling comes like, okay, what is reinforcement? It's such a huge word. Mathematical interpretation is very difficult, but at least some feeling should come from these words, right? So, reinforcement meaning, when you have implemented some model, it has interacted with the environment and then taken a decision. So it's a real-time decision, right? So when will that happen? This driverless cars, right? So if something is coming, there are sensors. So the sensor sensed it. What if the sensor stop working? Of course, bang, right? So that is why the sensors has to be very good in there. And then on top of that sensor, we have this reinforcement learning. That is why those cars are able to do a better job, right? There are many, I mean in US they are doing it quite a big level. I mean in India we have not seen that, hopefully not, because again US is very easy. You drive in a line, you have lines, lanes, right? You don't do this, right? So that makes it easier life. For here, we need a better mindset of people implemented in an algorithm, right? Who can come from where? I think the most easy is you're moving, anything is open, anybody can come. So algorithm has to implement all that. Just in a joking way I'm saying, but I think that is how then it can be implemented, but we are far away from there. So that was the simpler examples. So see, this is what, win the chess game. How? Position of pieces on the board, right? This is also real time. The way you move, you can't implement supervised or unsupervised here, right? Why you can't implement supervised? There is no label. Unsupervised, there is no pattern. Because it varies real time. The movement I am doing, right, in the chessboard, based on the way I am running, the algorithm will re-implement, right? So that is where it will be reinforcement, because it will see the environment, how I am moving, how opponent is moving. Then it can predict. You might be knowing this in the chess, whatever World Cup, I don't know, sorry, what's the name of that, the game, the final which happened, it was predicting in TV, right? Who has a chance of winning. How does it predict? It includes this reinforcement learning. So at least some correlation you can see with these slides which we're trying to do here. Okay, what else? Okay, you can forget that last one. So I hope the three types of machine learning is clear, right? Supervised, unsupervised, and the reinforcement learning. If you want to do machine learning, you need to know those technical details. If you just want to have a feeling of it, this is how you can always, I think, remember. That's how I remember it, I mean. Okay, so now example of task and paradigm. So you tell me, if you have to predict the outcome of a cricket match based on the previous result and stats, which one we will use? So I have an answer here, I should not have done that. Supervised learning, but why? Can you tell me? We have labeled data, right? So we will use supervised learning. Then, this is all machine learning for my field, but simulate new particle physics data based on a random collection of recorded events. Meaning you have recorded some events, now want to simulate. So of course unsupervised, because you don't know, there is no label. So you will make cluster of it. Okay, have I bored you enough? I have short, because they told me to speak for 1.5 hours. So let's hold for 2 minutes and then we go. Now these are specific examples of machine learning and high energy physics. So I will not take you into a lot of details, but like I will tell you in the way like where it is useful. I'll tell you a problem and a solution which we are getting through with machine learning. I think that will be. So when do generally people stop? Exactly at 11. There must be a time for QA in case you want. But so shall I speak for 15 more minutes and stop? Huh?
Madam, 1 minute.
Huh.
Madam, when you take small 5 minutes, you come from that high energy particle. Actually, we are undergraduate teachers, madam. All maths is chemistry. So, what are the tools, basic tools that you are using presently for your while interacting with your students, like content generation or like that? We are simply using ChatGPT.
Oh no. We don't use ChatGPT. I don't use.
That's what actually we are expecting.
No. So see, understand. ChatGPT is LLM. That is very different. What we are doing, okay, I think this is a good, instead of going through highness, let's talk about this, I think that is better. So, understand there is a difference of machine learning here. What you are talking about ChatGPT is a large language model. What is it doing? It has taken all the information from the entire world, put it in down there, running it. That is very different from a multivariate analysis. Multivariate analysis, what? I have a data, okay, it's a real data. And I want to predict something, right? I want to predict whether the particle is what I want or not. So what I am using is multivariate technique, for which I can use MATLAB, okay? For you guys, why I'm saying MATLAB is, that's the easy, I know it's costly, but it's the open software. In my field, physicists have written their own softwares, okay? We have a software called Root, which implements everything, CNN, ANN, GNN, we use all these algorithms to do what we want. So the algorithms are ANN, convolutional neural network, graphical neural network. What is the difference in simpler terms? ANN is what? Artificial neural network. Do you guys, anybody said anything? You have input layer. I know it's really boring if you don't know the maths behind it. But you have input layer, you have output layer, you have hidden layers. Right? You are propagating. And then you are predicting something at the end of a day. So algorithm wise in my field we use ANN. We have a lot of data like pictures. We use image processing. Okay, using image processing we can predict electron will look like this way, jet will look like this way, the way they interact with the detector. So I can use image processing algorithms there. So then I can predict whether this is a particle, I can classify the particles using image processing, okay. So that is another thing. Then, I don't know if you guys know about FPGA.
Madam, this syllabus speak on this.
So, syllabus said all this, that is what I spoke in the beginning, right? The AI in, that was my first slide. I don't know if you paid attention, that extra, I tried to cover all those topics, that was my first slide. AI in astronomical research, then AI in climate modeling, right? Then AI in, I covered all those topics.
Like an application part you have mentioned, madam.
Yeah, but then see, if you, otherwise, if you want to go in details, that is how you have to go in details. Because you cannot follow unless you follow the field, right? So they have written sun, right? And they know I am working on sun. So they knew I can go in details about sun. So they told me to cover the topics like application and then go for one topic in detail. That's what we can do, right? You don't want to hear this, I'll stop here. That's what I told you. I don't want to bore anyone. It's not my aim in life. I never bore. Even if my students don't like it, I just stop there. So, showed material science. I showed you that. See, I am not an expert in that field, right? So, semiconductor, if you go in details of that, okay, I can say you that you are making a material, right? So, you have to optimize the properties of that material. Then you go for synthesis, right? If you don't know even these words, how can you understand how AI is going in there, right? So, understand. So, first of all, there has to be a topic of interest, right? The theory which goes in that topic. Then you put in AI into that topic, right?
Madam,
So,
any more related to material synthesis and
material science. Yeah, so basically see, all this AI,
You have already artificial neural network and convolutional neural networks, which are going to be implemented. These are the algorithms which are going to be implemented for analyzing your data for example.
for anything, everything is a data these days, yeah.
What's the difference between these algorithms and AI? Power AI, what's the advantage you get?
Oh, so nobody, I thought this is something for last 2 days though. Nobody came and tell you what is AI, then what are these algorithms? So that is, okay, wait. My job was to give you application. So you're talking like a computer science point of view. So that is why I asked it very clearly. Last 2 days, what were told you actually?
Software which is going to be analyze the data, give the practical interpretations according to your wishes.
Correct.
So how then AI is going to be implemented how are these broadcasters so that you will get more benefit.
ANN is AI only. ANN itself is AI, so I am missing. You are missing out. AI is what? Artificial intelligence. Okay. What does the word means? You are creating an intelligence which is artificial. We are intelligent. We have our brains, right? Okay. Then you go into different models. Okay. So ANN is one of the algorithm which implements artificial intelligence. I am very sorry to hear that this has not been clarified to you guys till now. Okay. AI is a common. Okay. Let's say world. Within that we have physics, chemistry, life science, blah, blah, blah. Within physics there are different fields. That's how it is. AI. Then you have different algorithms. ANN, CNN, GNN. Then LLM. LLM is the recent thing, right? ChatGPT is the recent thing, which is large language models, right? Which came into picture. G. See, graphical neural network. What is graphical neural network? As I told you, you have graphs, meaning pictures. If you let me go here, maybe you will follow something and correlate. But that is where I had the examples like how image processing helps you. See, everything is a data. Why your laptops phone are recording everything? It's a very useful data. They are earning a lot, right? We say accept terms and condition blindly. But they are recording a lot of things, right?
Can you have answer session?
I have not been told. I was given this one and I think somebody may come and give you that. This is like a very, see, you're asking me as an organizer. I'm not an organizer of this event.
I'm just asking you whether you can
So I think somebody would do that because there is a lot of,
schedule.
I have no idea. I was told this topic and I'm very sorry that
I'm asking you. Out of
I can do that, but I have not been told that. So I think somebody from computer science might be doing it. Is it not there in your schedule? This is 5 days or 10 days? See, in order to do that tutorial, like this lady is right now very confused what the hell is going on. Do you know Python? Do you know C++? Here goes your answer. You need to be expert in Python or C++ to write anything. How can you do image processing without even knowing? Are you getting me? Because that is why, see, I spoke in a very, because I knew that you need to know your target audience. I know my target audience. I asked them many times, what is the knowledge base? Because see, to do a tutorial, how, think. Ma'am, you're contradicting yourself. I'm sorry to say. AI is all about coding, right?
need not to learn the code, we not only need applications.
Baba, how? Oh,
Yes. We are asking.
okay. Maybe you're missing out here. You need application. Okay?
Applications using the ready-made platforms.
But that, come on. How can you teach that to anybody if you still don't know what is the code inside it? Students are very smart these days. I am telling you this. I don't know what you get. We get like extremely smart students. You cannot play with them. They will, first question they will ask you, how can I write it on my own, right? So if the expectation is that ready-made code is there and you just put a button like /, that's what you want? You should tell your organizer this. Computer science can do it like this because they will have, because my thing if you want to do, see I am expert in HEP with data analysis. You need to first understand my data, na, right? If you don't even understand my data, if you do even /, like see, this is the application, I can give you a code for this. These are different particles, look different, right? This is image, right? This image is different from this, right? At least this third image is different from this. What is the difference? It is more widened, right? This is more widened, this is more in this direction widened. So using this image, independent of physics, I can predict something. If I train my model with many images like this, then on a new sample, my algorithm can predict, is it a C type or a B type or a A type, right? Independent of physics, forget physics here. If I have these three images, there is so what is the difference in the images? In the properties of an image, right? So if the image is different in terms of property, meaning it is more elongated in this side, it is more elongated in this side, plus if I put more parameters to it in a training, right? Then it can easily predict this is what will be the image preprocessing, right? Right? So you can put a GNN on it. Now what you're asking here is, you have no idea about GNN, you don't know C++, Python, but you want a code which will run this for you. I'm telling you it doesn't, it's impossible. You should ask, after you learn this theory, then you should ask a dedicated, 5 days thing which starts from very basic. If you don't know even C++, Python, madam, it's very difficult, I mean. This is
Actually introduced for the degree students, all the degree students, not the computer background students. This is the syllabus is there for BA, BCom students and BSc students. So without knowledge of any computer algorithm and all, they have to know the applications of AI, how it is working in different fields. Like how we are applying AI in visualizing the astronomical this data, or how we are analyzing the data using this AI. Only the application part. There will be what it was told is there will be ready-made platforms for that. We don't know.
Maybe somebody is going to teach me after that. I don't know the schedule, right? So there has to be some tutorial based, because this is just 1.5 hours, right? So I don't know what is 11 to 1 going to be, right? There may be somebody who will come and teach you something, but according to me that is extremely difficult, I mean.
So you are the only resource person to teach the AI in physics for us.
There is only one session for AI in physics.
Yes. And there are 3 topics.
Oh my God, that's like, so this program aim is to, you will go and teach that to students.
And we are also from different backgrounds, means without any computer background data.
So if you don't know astronomy, how can you tell a student about astronomy background data? See, you need to know, I work maybe in a very different style. You need to know a theory behind a topic. You need to have a good computational skills, right? Then you can show somebody something. And bachelor students these days are extremely smart. If you want a data, CERN has a public data. There is a site which has a public data and it has all the instructions in there.
Public data set, the repository, we need to know where we get the data, public data, and how are the platforms to visualize those data. That application part.
Okay, so that I can point to, I can talk to organizer, and that information is all there, publicly available. So if you want to run those things and you want to know how to run it, all that is documented. For that you don't even need a tutorial, just run commands, /cd this. I mean, do you know even Linux operating system, right? You need to do it on a Linux operating system, not Windows. It doesn't work. You need to have a line. देखो मैडम कैसे होगा? It's not possible. Government is what the hell they want. I'm sorry.
Motivate the students towards AI.
अरे बाबा motivate, but it's not even half-baked knowledge. It's
Framing the syllabus is different. What we are learning here, that is different. Framing the syllabus is different.
who framed the syllabus?
Absolutely. They will guide us.
Who?
State council.
Council for higher.
It's hilarious. That's all I can say. Unit 4.
In unit 4, part of it is there.
So what we can do is on data set I can definitely point you guys because it's all available. But the only thing is you can use that data, you can run it. Okay, what you will follow out of it, that's not my guarantee. I was trying to teach you that, right? But you need to have a subject knowledge. You need to have a knowledge of if somebody is following me, can understand me. I am really laughing at AP government. How can they even expect that? If a person doesn't have a subject knowledge, if a person doesn't know even what is Linux, if a person doesn't know what is CD, change directory on a Linux terminal, how can you teach a student to even have a feel of AI? That's impossible, right? Okay, you want to teach a student like run, 5 lines run, see something, you got something. You don't know how to analyze it, you don't know what to interpret it, but you have run something. Is that what we want? Looks like your smile says that. So I can point you to I will get in.
They are interpreting. That interpretation also can AI.
So that is the difference between a AI versus still researchers are required, otherwise AI will overtake everything. AI can interpret, but the knowledge which a human mind will bring in, because I have me or whatever, other scientists will have a knowledge of the entire field, which AI will only get through reading books or whatever you have fed in there. But a human being will have its own interpretation also. That is on top of it, right? That is why I feel AI cannot replace teachers. Because this human to human interaction which you need cannot come from a machine, right? Machine will come and speak for 1 hour without understanding you are following me or not. I am trying to change my tone based on maybe reinforcement learning may do it, but it is long way, right? So the human interaction and interpretation will make a lot of difference, I think. So as far as data is concerned, CERN data set is publicly available. People are analyzing it, people are doing it. There are instructions also there, okay? If you want, I can provide all of you that.
We will give an introduction about CERN and we will give.
So you really have to, what you learn here, you have to do it somewhere. Sorry, I have no idea. I was told to give this talk and I came and gave this talk.
So, show the study of CERN.
Sure, I think this is very much possible. So CERN data repository is public and there are commands which are there. But madam, if you don't know C++, Python, I don't know, but run the commands then, like something,
Will be here till Friday. Will be here till Friday.
You want me to take another session? I am extremely busy actually. Okay, let me try. Actually, my students are also at CERN, otherwise students would have done a wonderful job also because they play with the data, right, every single moment. Okay, let me try.
One hands-on session.
But I really, because I am teaching tomorrow, I am teaching day after. That was the only day which was free for me, so sir told me, okay, come today morning and do this. Say again.
Expose and discover. By vector interpretation. By 2 quadrant collision, 2 non-electrons collision, 2 quadrants collision. So, every collision is finding the peak.
No. So that is what collision is happening, you are getting particles. That is one event. So many collision happened, many events you collected. In 100,000 event, you got one event of Higgs boson. That is why you see only small events had that peak, otherwise it was a falling spectrum, right? So that is a background. Peak is only in one region and then only for 100 events. Okay, so that is why it's a problem of needle in a haystack. Meaning you're finding a needle in the big sticks of hay. That is why it was very challenging. And you need a lot of data. So we ran for like 3 years. So for that, great question. You saw something at one point, you saw a peak. Okay, so you saw something is there, it's new thing. It's not matching your other backgrounds. You saw something, let me complete, You saw something, then we do statistical interpretation. I don't know if you know probabilities, likelihood, test statistics. So we do all that. For a discovery, you need 5 sigma discovery, meaning the probability that what you say is a signal, the probability of that is very high. Okay, that what you are claiming is right is very high. You have to go to that is a 5 sigma discovery, we call it. That is why, how do you believe it? You see something, you know what, one experiment, you saw a peak long back. Somebody told me, my senior professor, they found the issue was the cable was not connected correctly and people said they also discovery. So that was so stupid, that happened once. So because it's so much electronics is there, right? You can miss out also on many things. But here we made 2 experiments, CMS Atlas, both confirmed in different channels at the same place, then only we saw. So there's a lot of statistics involved. So there's a lot, engineering is there. That is what, you collect more data. Okay, so the parameter which tells, is the luminosity, number of events per unit area, per unit time. That luminosity defines how many events you have collected. It's like the first discovery happened with 20 femto-1 inverse of data. Okay, so that is a...
CMS across the different cases?
They are nahi. So, Large Hadron Collider is an accelerator, I told you. Then I said there are experiments. CMS is one experiment, compact muon solenoid, Atlas is another experiment on this site, on this collider. Because the particles are moving, they have to collide and then interact. So the point where they are colliding is one experiment. The point where another one is colliding is another experiment. Because once you collide, then you will see lot of particles. It's like 1,000 particles in one event. Then it's like background. You have to find. So then it becomes a data analysis problem, right? You are looking for one thing in a 1,000, very noisy background. Like this noise is there, right? See, you are in a crowd. Noise, everybody is talking. You want to find her voice. So that's a signal for me in everyone. So that's like, okay, so other things are called background. We knew that, so that is called a model. Standard model predicted it, meaning theory predicted that there has to be some particle which is giving mass to everything, and then in the experiments we observed it. That is called observation. Theory will predict it, experiment will observe it. Haan.
But AI can be used for determination of structure.
See, I am not a semiconductor expert. So if you say me tool, see, understand the difference between the tool and the algorithm. You can use MATLAB. MATLAB is a tool, right? You can use MATLAB and implement any algorithm in it. Just the data will change.
Don't know how to.
So that is what you are asking questions generic. But
Actually, I am a chemist now. I have done the synthesis. I want to know the crystal structure. How can I analyze? That's my question.
you have to hear a chemistry guy. I am not a chemistry person. Because semiconductor physics is also a physics, right? Haan.
For determination of crystal structure. Based on that,
I am not an expert. I cannot answer. But if you want to know generically, you can use any platform, right? We have this MATLAB is very easiest way. You can take any data, implement any algorithm. Now crystal structure is like whatever simple knowledge I have about chemistry. Crystal structure, you mean FCC, all this, or what is it?
from XRD,
Okay. That is a different, no, not my cup of tea. Yeah, I know people talk about XRD and all, but it's not my cup of tea. I cannot answer that question. Somebody in chemistry, when they come, they can answer, yeah. I don't know who is coming there, but...
because we put the application like function control that is acknowledged.
So you have an exam also?
Yes.
But this is not chemistry, this is physics we are talking here, right? Okay, I cannot argue there more, I think, or answer that question more. As far as data set is concerned, I can provide you CERN data set, and it has, the web page has all the instructions because many people are using that public data set, and that can be done to show people like what can be done, but that is something, if you need a tutorial, I have to really go back and see like who can do that. Students, I wish they were here, they could have easily done it, but
Can you provide us some data sets related to physics?
That's what I'm.
Examples.
That's what I was saying last 1 minute. So data set for physics is available on websites, publicly available. I can give you that. Okay?
Can you give some examples?
That is what, there is a website which has every information. It tells like how you can do that. That is, there is a very good public website which CERN maintains, which has all the information. So I can provide you that. So if I'll talk to organizer and get an email ID or whatever, like I'll share the information, see, or if you want to be in touch with me, you can take my number. In case I didn't put it, but 9873 416985. And my email ID is 416985. And my email ID is bhavna.gombar@UHYD. My name @UHYD.ac.in. Oh, this is interesting. So AP government wants people to learn this and tell this to students. Instead of that, send students to places like for internship. That's better, right? Because then they can get a better training from the experts. Like we get internship students, right? I get a lot of students, but it requires 3 months.
Every year they have a separate set of students to send someplace, right? The teachers that train, the same teachers can keep on training.
That makes sense. But then you cannot train teachers in 5 days.
Yeah.
It's impossible. What are they talking? I mean, it took us years to, come to a level and speak this much, right? It's impossible. This is gossip. What happened in last 2 days?
Madam, like,
This is computer science thing. Data, computer science has a lot of data.
madam, like they want to.
This is what happened last 2 days.
No, ma'am, actually, learn about the infrastructure. In the second
Theory.
Theory part, in the second unit, you learn like data, types of data, and data processing,
Again theory.
and then in the lab sessions, we have learned how to use orange data mining to visualize the data.
So you have that knowledge. Then how did you learn that? Using what tool? In the lab session? Which software?
Drag and drop kind of.
Orange
Data
data mining, we have
visualization
downloaded, we have opened, we uploaded the data set, and we have visualized the charts. Clearly, that by linking that. The pre-processing we have done like
Drawing bounding boxes.
And what is the day schedule now after 11?
Lab session.
lab only.
Lab computer science.
It's not as in chemistry lab.
Without any theory of chemistry lab, huh?
Yes,
Acha, okay. Okay. So then what is the worry? You will get at least through chemistry. So for everything you need to get a... Who prepares such syllabus? It's horrible syllabus. Huh? Can I see if you don't mind? I don't know if you have to go.
Today we have a lab on material science data exploration.
So it has this now, madam, material science data exploration is there for you. Why are you worried? Next class is material science, but they will tell all this XRD and all that. That's what people do. I don't know who is doing it, but if somebody is coming from here, the material science person will do it. Jovan Jose, huh? Jovan. He's chemistry person.
Yeah, he took one session yesterday on quantum chemistry.
Quantum chemistry. But I think that will have what you want. He has that?
And so far we had these
Ranjit, acha ye wahan ka hai, I know.
public data sets and then infrastructure, then foundations of data pre-processing,
Okay.
then data annotation.
Yeah. So my thing was theory. Thank God. My thing is theory. I never said I'm going to do a lab because I knew I don't have time. It requires a lot of time to prepare for somebody, right? Okay. But I will still try. I will send you somebody, if somebody message me on WhatsApp on this number, okay, that will remind me. I'll spend my day today and I'll give you at least a place which you can see and run things. That I can definitely do. Material science तो मैडम chemistry है आप high energy physicist को XRD पूछ रहे हो? How is it possible? Okay, I am done. Huh?
Take admission.
Huh?
Take admission.
So you can have CU set, I think. See, we changed many times. So please see the prospectus, I would suggest. Sometimes we had our own entrance. Sometimes we went through common thing. Abhi still that discussion is going on. Which mode we will go through. So CU set, I think, as he is saying, did you read somewhere? Because right now the admission prospectus hasn't come out. So CU set, if you see, we're definitely not going through our entrance. CU set. Is that true?
Internship program.
That happens. So students can apply for that. So that's why I sent you this CASES website. You can look through that. There are many things there. We have 8 faculty on many different areas. So you can contact them, and we generally take, like I take many students for internship, so that's not a problem. We do that. Yeah. And I'll be happy to take students who are, but some knowledge of C++, but don't send me people didn't even know LX plus, that's impossible. It will take 2 weeks to do that. Okay, thank you.
Thank you so much, ma'am.
So you can see about CASEST website. We will also post it there. CASEST, CASEST, SEST, SST. This is a department name. T.
Everybody came? Okay. Good morning to all of you. So this particular session is basically a lab-based session. So before I start, brief introduction about me. I'm Pramod Kumar Mishra. I did my PhD from the same university, same institute, 2007 to 10. Then a postdoc from IIM Bangalore, and worked for about 3 years at Gitam, Visakhapatnam, in the area of operations in the decision sciences. And for the last 10 years about, I have been a faculty here. And prior to my joining my PhD, I have also done my MSc in applied mathematics and MBA. So recently I got certified with American Production and Inventory Control Society with the designation of Certified Supply Chain Professional. So basically my area is operations management and broadly the quantitative techniques. So we basically say management science or the decision science. So this particular session I have is training and testing, right? We'll be basically going for a kind of hands-on session, not really with the PowerPoint presentation. This is just for the reference. I'll be time to time showing you how actually you should go ahead with the few algorithms. Okay. So broadly, I think Orange software is available more or less in all the systems. You can also have a look at it quickly. It is a very user-friendly software, and it's a basically a contribution of the Python, right? But despite it's being very supportive in terms of the hands-on, it doesn't have much features like Python. So in case you are more interested in machine learning, right? So I suggest you to get into some kind of coding. And relatively coding also has become easy with respect to the ChatGPT and other things, right? And also the Python has come up with the AI companion. So wherever the code doesn't work, you can take the help of AI companion to rectify your code, right? But anyway, this particular class is basically with respect to the Orange, and we'll be having some discussion with respect to the training and splitting, and with respect to the hands-on wherever needed. I'll just show you a little. So wherever there is, we see what is happening behind the scene, we don't really accept it, right? That is the characteristic of a mathematician, and so that is where I'll be showing you a little bit of algorithm and how things are happening with respect to mathematical stuff, and then you can take it further. Okay, so all of you have Orange, right? So you can just go to Orange and try to see. There is a data set called as Titanic. There is a data set called as Titanic. Okay. So what is that? Is the Titanic data set? I'll directly take you to the Titanic data set. So this is the Titanic data set, right? All of you have done something with respect to Orange by now. So you know that, right? So go to Orange. Orange can be installed directly from orangedatamining.com, or you can go to Python, that is Anaconda Navigator. Under Anaconda Navigator, Orange is already installed, or it is available. You just have to install once again so that Orange will be activated, right? Now, you can also have the standalone software with respect to Orange, because it gives a little bit of you can say the flexibility, so that also you can do. Now, session is training and testing, right? But there is no model as such is given there. So I'm not very sure what kind of models that you heard discussed in the class, but I'll be giving you a little bit of essence of it when you go for the model building, then you go for the hands-on. So now this is the data set. As you can see, the number of observations in the data set is 2201, and there is a column where you have identification number, which is purely nominal, and you have gender. Gender is also a nominal variable, also called as categorical variable. There are two categories in this case. There is female and male, and the age is also categorical in this case. They have given in this case as adult or the child. Then class, which class they are basically traveling. Titanic is basically the data set in the Titanic, that ship, right? So from there it is. So there are three classes: first class, second class, third class, and the crew member. That is also purely categorical. Then the status is whether after the accident, whether someone has survived or someone has not survived, right? So as you see, there are 2201 records. So purely they are all categorical records, right? You may say, why I am using this particular data set? Because I have been given the task for using this data set, right? In case you would like to use any other data set, you can use it. If you have any doubt or something, you can come back with your queries. So we are there definitely to help you. But this particular data set is Titanic, where you have 2201 records. Now, as you see, they are all categorical variable, right? So all of you are from mathematical background, may not be very much familiar with this. They are actually qualitative in nature, right? They are only qualitative in nature. They are not numerical data. They are categorical or the qualitative data. You can have the number just to execute the software, but you need to understand that they are purely categorical in nature. So wherever there is a mean, standard deviation, those things are taken into consideration. You should be little careful to use, because for mean and the standard deviation, we basically take the data should be numerical in nature or quantitative in nature. So now this is broadly the data set, right? So what you can do is you can go to Orange, right? You can go to Orange. So once you open Orange, it will be looking like this. Now you create file. Maybe parallel you can do it a little bit faster. So once you do that, then there is a data set called a Titanic. If you are not able to see Titanic, there is a folder here with the three dots. Just you click that, right? You will be seeing that there is a data set called a Titanic. You go down for the Titanic.tab. Okay, so that means when the data has been created, tab has been used for separating the values. Okay, it can be with comma separated values, it can be tab, it can be any other character, but in this case it is a tab. So once you open that particular data set, right, are you able to see this data set, all of you, right? So then you just open it, right? In my case it is already open because I did some exercise. So you just open it. Then once you open, you will be seeing this particular screen where you can see status is basically the you can say the class, where it may be crew member, they may be traveling in the first class or second class or third class. Then age, the features are adult and child. Then the gender or the sex is basically categorical, that is female or male. And survived is again categorical, that's a target variable, which is no or yes, right? No, yes, yes. Sorry, you didn't get the data in. Go to your Orange. Okay, so after that, I'll just show you once again. Those who have any trouble, you are on mole, right? You can just help me little where people are facing difficulty. You have some idea with Orange, but you can just have a look at it. Okay, I just close it once and open it fresh. Please pay your attention. This, at least you are able to see this, right? So once you right click, or also there is a drag and drop. You can drag and drop. Otherwise you can right click and type what you exactly want. I feel typing is a little convenient, right? File. So once you have the file, right? This is the file. So double click the file, right? Once you double click the file, then if you are not able to see the data, just to click this one, the folder with the three dots, right? Then you will see there is a because you also need to do something because it's a lab class, and I also don't want to do it a demonstration because you also have some take home. Yes, I've done now. So what about you, madam? Both of you are able to do it? Okay, so more or less, you madam? Yeah. So then everybody more or less on the same page. So if you close, then you see these are the few things I have already shown you in my PowerPoint presentation. Then I close this. So I have the file. Now, very simple thing, once you have a file, you must be interested to read the file, to see the file. So if you want to see the file, just to connect this, these are called as widgets. These are called as widget, widgets in this case, but in Python we have libraries. So behind them is the algorithm, but in Python we have the code. That's the difference, right? This is very user friendly, but Python is not very user friendly. You need to have a little bit of coding to read your data files, right? So once you have the file, then you do one thing, you connect that particular file with something called data table. Okay, just to create a data table, right click, type data, then something will come, data table, you just click, then data table widget also will be coming to the screen. Then once you have this, then you take the right click, you click it, then you connect it to the data table. From here, you click and connect it to the data table, right? Are you able to do it? How many of you are able to do this? Connected. Now you double click and see whether your data is available. Now you connect and see, are you able to see your data? Right? Not? Any problem? Why don't you change your system, madam? Do one thing, in case you are not able to do it, there is some difficulty, please look at my presentation, note down the thing, and then you can practice it when your time permits, right? Because my time is short, I cannot attend multiple times. So in this case, data is read, right? Maybe some of you can help, others, those who are having trouble, because if I go there and come here, so a lot of distance I'll be covering, so ultimately I cannot complete my class properly, right? Because I'm also a person from operations, so we see that. So please help each other, and any difficulty further, I'll definitely come and rectify. So very simple. So this is the data table that you are able to see. How many of you are able to see this data table? Very good. So more than 50% at least. So this is the data table that you are able to see, right? Now, we have already understood that the first column is basically the target. Okay. What is the target? Once there was the Titanic, that ship met with an accident, then people started drowning, right? So some people were saved alive, and some people died eventually, right? So this is what is the data set. Now whether they have survived or they have not survived. So if they have survived is equal to 1, they have not survived is equal to 0. So that way it is purely a dichotomous case, right? Or you can say in mathematical form, survived is equal to either it takes the value 1, right, or 0. So there are two values, right? So now we have to build a typical model that will be helping us to understand what has really happened with respect to the typical case, right? And if the similar case happens in the future, maybe what need to be done, some kind of precaution. Of course, that data is not available in this case, but you can think of how this particular prediction is going to help us, right? So I just close this now. Then what is that I am going to do? Now what you need to do, you create a simple thing. I am not doing anything at the beginning. You just create one model. You just take one model, right? Let us say logistic regression, right? I have 4 or 5 models for you. So logistic regression. So what is a logistic regression? I'll tell you a little later. But before that, you go to logistic regression. Just see whether logistic regression is available. Just type there logistic. Somewhere you will find logistic regression, right? Logistic regression is a regression that takes into account the probability in the model, right? So basically we have 2 types of models, right, in the regression. So you can take y is equal to mx plus c, is a simple straight line equation, which also can be treated as a regression equation. Otherwise, ln y is equal to ln p by 1 minus p is equal to mx plus c, right? So this is the logistic regression equation. Now, possibly some of you might be aware of it, or some of you may not be aware of it, but I'll give a little bit of essence how it really works. So now you see the widget. After you see the widget, so what happens there? You now connect file with the logistic regression. Okay. So logistic regression is basically a learner. Logistic regression is a learner. What is a learner? Learner in the machine learning is an algorithm that basically talks about how you can solve a typical problem with the learner. It is learning, right? Logistic regression is already algorithm is available, and now you are supporting the algorithm with respect to the data. When you give the data to the algorithm, now algorithm will try to start its work, right? Similar to this, in the Python also you have the libraries, and when you pass the data through the library will start working. So in this case, you need to connect, because learner has not got any input, it cannot work, it has to get some input. So please connect with the logistic regression. So just drag, just connect them with this. So file is your input to the logistic regression, right? So once you connected this to the logistic regression, right? Up to this is clear to everyone? For learning a machine learning model, why we are saying it's a machine learning? Can anybody tell something about it? Machine learning, what is the benefit of this machine learning? Why we are doing it actually, and how it is becoming possible? Earlier days, what was not happening versus these days it is happening, and there is a lot of hype about it, right? You all know that AI, ML, everybody is talking about, right? And now AI is going to take a lot of jobs also, right? So that is the fear, kind of fear. But let's see how it goes down the line. But anyway, so what is happening with respect to the machine learning is we are basically training the machine in such a way that they learn from the data and the algorithm. You need not feed all the times the code. The code is already available. You just declare what is the independent variable, what is the dependent variable, then the codes will be automatically work to give you the results, right, or the output. So this is what is the typical thing happening with respect to the ML, and it's a ML means it's a you can say the lifeblood of artificial intelligence, right? Artificial intelligence, if you see, this is the lifeblood of the artificial intelligence. Without any algorithm, it doesn't give you any result. So this is what is the learner part, right? So the learner part, now I have connected. So if you want to see what is that is your regression coefficient, what is that is your regression coefficient, what you can do, you can connect this with one more table called data table, right? You connect this with the data table. So in this data table, there is something called, once you connect it, it will show you whether it is coefficient. That way it is very user friendly. Is it coefficient? Yes. Then coefficient will be coming from the data. You just connect there, right? How to connect it? I'll just close it and open it once again. Close it, just to drag and drop, right? Right? Coefficient. What is the coefficient in this case? What is the coefficient in this case? M is the coefficient, C is the constant or the intercept, right? If you mathematically represent or geometrically represent, this is nothing but your C and this is nothing but your M, which is nothing but your tan theta, right? So M is equal to 1 means tan theta is equal to 45 degree, right? So theta is equal to 45 degree, right? So that way it is going to pass through this line and this is your intercept, right? So this way you can have a little difference here. The right hand side, as you see, it is same, but the left hand side there is a difference. What is the difference? This is actually natural logarithm p by 1 minus p. That means event is happening versus event is not happening. If you toss a coin, if you get a head and head is your favorable event, then you can say it is favorable event, the probability is 50%. If a probability you are not getting head, you are getting tail, the probability is also 50%. Now what is that is the ratio between head and the tail? It is 100%, 50% by 50%. So they are equally likely event. They are equally likely event, right? That is probability of head and the probability of tail, they are one and the same. So that is where we have to take in this case, and the interpretation is a little difficult in the sense a little different here. What is the interpretation? in this case, the interpretation is very straightforward. If you increase 1 unit of x, then it is going to increase y by m unit. That is interpretation. But in this case, if you increase 1 unit here, then your y is going to increase by e to the power m units, because there is a ln here. So you have to take ln both the sides, right? I'll quickly demonstrate you a little bit of the algorithm, but my focus is on the hands-on. So little bit of algorithm you can appreciate after you go back and you work on this particular part in case you are interested. Otherwise also fine. So now press OK. I hope you are up to this page. Okay, right? Now if you click here, you should be able to see the regression coefficients. You should be able to see the regression coefficient. Are you able to see the regression coefficient? Intercept is equal to 0.2, status is crew is 0.1, status is first is equal to 0.9, second is equal to this, third is equal to this, something like that, right? Now, what is that we are going to do this? In this case, this is what is the regression coefficient that you are able to see. Now, what I am going to do is, I would like to connect another widget called, connect it with something called test and score. Okay, another widget that you connect with this is your test and score, right? So if you want to see test and score, means the model will be predicting for all the observations that you have. So how many observations are there? How many? 2201 observations are there. Now for every one, the model will be generating some output, and that output may be the correct output, that output may not be the correct output. Are you getting my point? Let us say you have fever, right? And now you are going for some test. You are going for some test, right? Let us say you are testing for malaria or maybe something else, right? Now, how many of you think that the result should be 100% accurate? It is not. Result may be correct, but you may not have, right? Because of some reason, you may have it, but the result may say you don't have it. There is also a possibility, because that is why we are using probability, no? Why are we using probability? Because nothing is certain, everything is probable. So that is why we are using probability. So that is the case. That means you have 4 different decisions right now coming into picture. What are those 4 decisions? Yes, you have a problem, test says you have a problem. You have no problem, test also says there is no problem. These are the correct decisions that has come from the algorithm, right? Now, what are the incorrect decisions that the algorithm has given you? You have the problem, but algorithm says, no, you do not have the problem, right? Now, what is the other way around? You do not have the problem, but algorithm says you have a problem, right? Or you have the problem, algorithm says you do not have the problem. So, yes, yes, no, no. These are the correct decisions given by the algorithm, that's the learner. What are the incorrect decisions? Yes, no, no, yes. These 2 are the incorrect decisions. Now the question comes here, yes, no is basically false negative decision, and no, yes is basically false positive decision, right? So any algorithm that you take into consideration, your idea should be to control false positives, false negatives, because you want more accuracy in the algorithm, and that accuracy is nothing but the true positive plus true negative divided by the sample size, right? You will be getting the correct predictions, right? Now you see, if you want to see the correct prediction, you want to see the prediction for this entire file, then you click it now. You can click it, right? So you can just, I have not given you the training data and the testing data. I am just doing it for the one shot data set. Then what is that I am going to do? You create one more data table and connect that particular data table to the test and score, right? So to the test and score. Now you double click this particular part. Now you double click. So what you can do is, I have to provide data to this, right? You can also provide data to this, right? So there are 2 things you need to give to the learner, that is, learner is nothing but your logistic regression, right? That connection should be there to test and score, data should be connected to test and score, right? You have to provide the data, you have to provide the algorithm, then it will execute. So it has executed. As you see, logistic regression, can you see the output, right? Output you have seen, connected to the data, connected to the data. The test and score, that widget should be connected to the data, should be connected to the algorithm. That is logistic regression. Then only it will give you the result. It's natural, no? When you are testing something, you need the data. So one more connection should be there. Once again, I'll show you. I just close this. See, so there are some intersections, so you are confused. Now you see, logistic regression is the algorithm. Algorithm file is giving you the test and score, right? Because for any algorithm, you have a theoretical process, you have a theoretical algorithm, theoretical process, and you also have the data. Unless you provide the data, it will not execute. You got my point? Please try to understand. It's a very simple tool. There is no difficulty at all in Orange. Only thing is that you need to have the right, connectivity. So very clearly, when you go for some test, you need the algorithm, how you are testing, right? And who is the person involved in that? Let us say you are measuring the temperature of somebody. What you need? You need a person, you need a thermometer. As simple as that. So thermometer is the device, right? And the person concerned is the input. You need somebody, right? So that is what exactly is the point. Why it did not execute? Because I did not give the data to it. Now I have given the data to it. So now it should work, right? So it has given us the values, and let us go to the test and score. You connect it. You need to see now. You need to see what is happening in the test and score. You connect it with one more table here. Unless you connect it, you will not be able to see. Tables are basically for the data visualization. You should be able to see it. What is that is really happening. So once you click that, you should be able to see something called table. Can you table? And you can also drag like this, right? That's not the very big thing to do here, right? See, now you please have a look at it. The actual thing is yes, right? And the logistic regression has given no, right? And why it has given no? Because the result is more than 0.5. The result is more than 0.5, right? So what is the probability of no? 59%. What is the probability of yes? 41%. So normally what happens in logistic regression, the cutoff is taken to be 0.5, right? So below 0.5 will be classified as a 0 or no. Above 0.5 will be classified as that is classified as yes. So that is what has been done in this particular case. Now whether this particular threshold, you can change it in this orange, I am not very sure. You can probably check that, right? You can make a note of it and check whether this particular threshold can be changed to some other value, maybe 0.55 or 0.6 or whatever. This is a very, very practical problem because, basically in the machine learning, fraud analytics, right? Especially financial fraud, right? Let us say you are going to the bank for a loan, right? So now your data can be given to the machine, and machine will be telling whether you should be given the loan or not. So what are the inputs you can give to the machine? Like how we have given your gender, your age, your educational qualification, where you work, how many years you have been working in the current position, how many years you have worked in the previous career that you had, right? What is your salary, what is your past salary, right? What is your credit score? Then it will tell you whether you should get a loan or not. The manager may not really get into your profile, right? The manager will have all the records that your credit score or everything is put together is fine, so you should be given a loan, like how this is given. So this is very interesting case, especially the logistic regression, right? Now, before I proceed further, little bit of algorithm part I'll just show you, so that being from mathematical background, you may probably appreciate. And I also being from mathematical background, unless I see some equation, I don't feel happy actually. So this is what is the algorithm. This is written for linear regression, just to give you a little overview. So you can see this is binomial logistic regression. So please try to be a little careful. There is no S after logistic. Okay, people sometimes write logistics. Logistics is part of supply chain, right? That is different. So this is logistic regression. So this I have written for little bigger, independent variables or the features, but here I have written for only one feature, right? Now what is happening here? The p by 1 minus p is basically called as the odds ratio, and the odds ratio, if you would like to find out the value, then you can find the probability like this. That is 1 by 1 plus e to the power minus a, b1 x1, b2 x2, and so on, according to the number of features you can proceed, right? And the p by 1 minus p is basically called as the logit. This is called as odds ratio, ODDS ratio. Odds ratio means the probability of a particular class in comparison with the other class, right? Someone is a smoker, someone is not a smoker. So what is the probability of a smoker with respect to the non-smoker? What is the ratio of the non-smoker with respect to the smoker, right? So this particular data is also very important, and this is also very useful in case of medical diagnostic, right? When people go for critical test, let us say for TB or cancer or something, so this also is very powerful technique, logistic regression, right? But the problem here is not many people are able to use it because of the complexities with respect to the probability. People from mathematical background or maybe some background in engineering are able to really appreciate this particular technique. Now, what is happening there with respect to the multiple categories? This is what actually multiple categories. I think you can let us see that. I'll be sharing this presentation, nothing to worry for. So presentation and some kind of exercise I'll be sharing with Lokanand sir, and he'll be sharing with all of you. Please pay attention to the algorithms. Now, if you plot this particular, graphically, so you'll be seeing there is a curve called sigmoid function. That is called as sigmoid function. So the sigmoid function for various categories, you can say 2 input category, 3 input category, and 10 input category, you can have different curve. That is basically called as the sigmoid function. And from where you are getting the probability of y belonging to a particular class given your feature is equal to this function. You will be able to get, right? So you can also do it manually, little bit of idea you will be having in case you are more interested, otherwise also fine. Then, so this is about the logistic regression, but now let us talk little bit about the output of the logistic regression, right? So as I told you earlier, there are 2 categories, right, of the dependent variable. The dependent variable is nothing but whether the person concerned or the passenger traveling in the ship Titanic, whether he or she has survived or not survived. So if survived is equal to 1, not survived is equal to 0, then how is your model going to give you the accuracy part, right? Now I'll quickly show you what is that is the matrix there, and that is basically called as confusion matrix. Have you heard of confusion matrix? Confusion matrix. You might have done some matrix, right? Matrix multiplication, addition, and so on and so forth. But here in this management science language, or the machine learning language, we basically call it as confusion matrix. So this is a confusion matrix, right? So what is happening in the confusion matrix? Please see the there are 2 categories. This is actual and this is predicted. Predicted means who has predicted? Machine has predicted or the model has predicted. If the actual is yes and the machine or the algorithm also has given you yes, then it is true positive. That means you have some problem and the algorithm also is saying that you have some problem. So it is a correct decision. The second case is basically actually there is a problem, but machine is saying there is no problem, right? So it is incorrect decision, and this is basically called as false negative. This is basically called as false negative, right? Now the problem may not be there, but the machine or the algorithm is saying that there is a problem. So that means it is called as false positive, right? So false going to 1, false positive. 0 is going to 1, 1 is going to 0 means incorrect decision, right? 1 is going to 0, false negative. 0 is going to 1, false positive. So this is false positive, and 0 is going to 0, it is false, it is true negative. So now the correct decision in this case is basically true positive plus true negative divided by true positive, false negative plus false positive plus true negative. Or you can say true positive plus true negative divided by the entire sample size. This is what is the decision that the machine will be giving you, because we need the accuracy. We need the accuracy. Otherwise, if you don't get the accuracy, what will happen? You will be treating the patient in the hospital scenario that little different way. The patient may not have the problem, but you are actually treating for that particular problem. Or patient may have the problem, but you are not treating the patient in that way. So both the sides you have the problem. So this is what accuracy is very, very important. Now there is a 3 class case I have given theoretically. You can just go through it when your time permits, right? Then model accuracy part. So have a quick look here. As I told you earlier, true positive by true positive plus false negative. This is called as sensitivity. This is called as sensitivity, also called as true positive rate, right? The other one is basically called as specificity, that is true negative by true negative plus false positive. As you can see logically, those I think all of you might have gone through logic in intermediate also. If you see, true is going to false, then negative is going to positive, right? So of the total, true negative means it is actually negative. It is negative. False positive is negative. Of the total people who are negative, how many your machine is saying negative, right? So that way you have to go for true positive and true negative, right? Then you can calculate something called precision. What is precision? Precision is nothing but true positive divided by true positive plus false positive. False positive is actually negative. So total positive, total negative. So if you take the ratio, you should be getting how many people have been correctly classified as a true positive, right? How many people have survived, right? Given the true positive and the false positive, right? That way it is precision. Then one more thing is the accuracy. I have already told you, this part already I have told you, the classification accuracy, correct decision divided by sample size, okay? Then there is one more thing called as F1 score, that is actually the harmonic mean between true positive rate and your true positive rate and the false negative rate, right? True positive, you can see true positive, then false, it is harmonic mean between recall and the precision, So this is also called as recall. So if you take the harmonic mean, right, what is harmonic mean? 1 by x1 plus 1 by x2 and so on divided by number of observation. If you get that, harmonic mean is not very much widely used, but in this case you can also use it for better accuracy. Then something called as Matthews correlation coefficient, right? That also additionally in the machine learning it has come. So that also will be giving you some accuracy. So what is that overall happening here is the accuracy. What is the model accuracy? That we are actually interested in. That I'll be showing you quickly when you go for the training and testing the model, right? So similarly, you can proceed with 3-stage cases, okay? Little bit of complex, algorithm here. In this case, you have to calculate. Then one more thing is called as the ROC curve. What is ROC curve? ROC curve will receiver operating characteristic curve. That curve will be telling us what is the total area under the curve and how that curve has been estimated. That curve has been estimated with false positive rate, FPR, true positive rate. This is actually sensitivity. This is 1 minus specificity. When you plot the curve with a different cutoff, you will be getting curve like this, okay? So now we have to take the curve with maximum coverage, maximum area under this. And how that has been calculated, you can calculate with this particular rule, that total area covered under that particular curve, right? So these are the few things will be telling us how we can measure actually the accuracy part in the algorithm, right? Now let us do the same exercise. All of you please do it and save it in your system any possible you can take it also. I'll be also sharing some kind of orange data sheet so that you can also practice. Now let us go to our data set. So this is what is the thing you have already seen. Now if you would like to see the classification or you can say the confusion matrix, right? So what you can do is right click, type confusion matrix. Confusion matrix has come. So now you can just connect that widget to test and score, right? Confusion matrix, connect it to test and score. When you do that, then click confusion matrix. You should be able to see the confusion matrix, right? What you see here, true negative is 1364, true positive is 349, people did not survive, and algorithm also said there is no possibility of survival. Correct decision. Then the algorithm, no, it is no, okay, not survived, they have survived, yes. So then people who did not survive, right, not survive, and also actually they did not survive, right, because of some reason, maybe more child, more adult, that you have to see thoroughly the entire estimation. Then people who survived, right, people who survived, and model also said they should have survived, they should have survived. So this is 349. Now what is the correct decision? The correct decision is this one plus this one divided by this one, right, divided by this one. Now let us see whether our test and score has given us any result on that. You can see it is yes. You can click now test and score. You should be able to see this particular screen. And what is that it is saying? The area under the curve is 76%. Why it is dangling? Any idea? Because of FDP. Oh, it is. Achha, it is coming. So I am not disturbing this, but still there is a vibration. Okay, so area under the curve is 76%, right? Looks like the model is not a very great model. Then your accuracy is 78%. So what is the error? 22%. 22% inaccuracy is there. Then what is that is F1 score? 76%, all as good as this one. Precision 77%, right? Recall is nothing but your sensitivity, true positive rate is 78%. Okay, then the correlation is not very high. Normally the correlation is covariance y, standard deviation of y, right? But in this case we have calculated with respect to true positive and the true negative, right? That is called as Matthews correlation coefficient. So looks like not a very great result, right? Now when you don't get a very great result, what are the things coming to your mind to see the better accuracy? One or two thoughts, can you please throw some light? When you do not see better accuracy in the model, what else you can do to get better accuracy? Yes, madam? You can switch to the different algorithm. Okay, do you agree? You can switch to different algorithm, right? So we'll take madam's opinion for the time being, right? Any other thought other than the algorithm? Any other thought is coming to your mind? Having more data, right? Any other thought? Any other thought? Maybe certain times you may have to treat the data with the outliers, right? What is an outlier? Value that is basically falling outside of -3 or +3 in the Gaussian distribution. 1 by sigma under 2 pi e to the power minus half x minus mu by sigma whole square. X varies from -infinity to +infinity. You can calculate, or you can take the quartiles, right? Q1 minus 1.5 times interquartile range, Q3 plus 1.5 times interquartile range. You can have some kind of treatment. When you have the data, you can exercise it, right? Now I'll go by madam's thought. So madam is saying that there may be other algorithm that may be probably helping us to have the better decision in this case. Now what could be those algorithms? I'll quickly take you through my algorithms. Not many slides, very few. So what are the algorithms? Regression is one algorithm you have already seen, right? The second algorithm is called as decision tree. The second algorithm is basically what is happening? Decision tree, right? So decision tree, some of you might have been working in the decision tree areas also. Now, what is happening in the decision tree? You basically have to have the entropy. When you go for a cutoff of a particular node, you will be diverting to different nodes. So you'll be using something called entropy, right? So negative, you have to take the negative of the conditional probability here. Then you have to take log 2 of the same thing, right? So C is the classification, which class it belongs to. Then T is actually varying from your with respect to a particular observation, right? Then you will be getting your at the node, depending on this value, you will be getting the classification, right? So there is another one also that is called as basically Gini index, but we basically take in this case entropy. So what is happening with respect to the entropy? Then let us say one more algorithm, random forest. There is not much number here. The random forest is the algorithm that basically talks about multiple trees have been created in the data, then the final prediction will be given on aggregating the results from all the trees, right? That is one algorithm, basically depends on decision trees, and it gives you the algorithm that is called as random forest. This is one algorithm. Then the third algorithm is basically based on the conditional probability, that is the Bayes theorem. So probability of A given B is equal to probability of B given A into probability of A divided by probability of A given B. A given B, then B given A into probability of A divided by probability of B, right? So that is what you calculate the conditional probability. And for multi-class problem or the multi-feature problem, you can use the conditional probability on the joint probability for calculating the probabilities. Wherever there is a higher class will be coming with respect to a particular observation, then you have to connect it to that particular class. This is one algorithm that is there with respect to the conditional probability and basically the Bayes theorem. Then one more algorithm that is basically, I am not taking too much time on this because we have to have some hands on. So then support vector machine is another algorithm. Basically it creates a plane called hyperplane, and that hyperplane you have to optimize, right? With respect to this is your optimization problem, right? You have to minimize subject to the constraint. W is actually the weight matrix, respected feature, then the bias is greater than or equal to 1, then you have to, where W is equal to norm of W, that is actually the distance matrix, right? So you can solve it this particular matrix. When you have this particular value greater than 1, then the class will be varying in +1, less than 1 it will be in -1. These are the two different categories. You can also take yes, no, yes is equal to 1, no is equal to 0. This is also you can take. Now let us do one thing. These 5 different algorithms will connect it to our test and score widget and see whether there is any change with respect to the accuracy, right? So all of you please go there. All of you please go there now. This one. So what is that you see here? Logistic regression, right? And that has been connected to test and score. Okay. Now you do one thing. Tree, right? Find a tree. That also you connect. That also you connect, right? Tree is another learner that is connected to test and score, right? Now after connecting this, please check whether your analysis has changed or remaining same. If it is remaining same, then there is some mistake in your case, we have to rectify. If it is showing 2 different sets of analysis, that means the test and score has learned from these algorithms, right? So let us see, go to the data table. Can you see? There are 2 different columns came, one for the logistic regression, one for the tree, right? So it is working, that means it is working. Now let us do one thing. Let us go to the confusion matrix. See the confusion matrix, right? So this particular confusion matrix already we have seen in the logistic regression case. Now let us see what is happening in the tree case, right? Decision tree case. So just you click it here. Data to the, not needed, because the algorithm is connected to the test and score. If you are connecting to test and score, the data is connected to test and score. That means the data, the analysis is already connected to the data set. You need to just connect it to the proper algorithm, right? Because you see, test and score is already connected. No, tree has to be connected to test and score. See, tree has been connected to test and score. So, logistic regression is one input, tree is another input, data is another input. So, how many cases, how many inputs are there? 3 inputs. Please do it once again. 2 input side. Input side, you have to give 2 input side. For test and score, data is one input, all algorithms are different inputs, right? Please check it now. How many of you are not getting? How many of you are not getting the result? Can you please close it and do it once again? Do it once again. Once again, I just show you, okay? See, how many of your cases is working? Can you please raise your hand? Okay, very few cases. Why it is not working in others cases? See, okay, first of all, remove tree and see whether it is working for you or not. Remove tree, just click tree, delete. Now you check whether it is working for you. Please check whether it is working now. Is it working for you? After removing tree, is it working for you now? It's the previous case, no? I didn't do any change. I just removed. Logistic regression is there, but tree I have removed. Now it is working. How many cases it is working? I think all of you said working, right? Earlier also. Now, please check confusion matrix. Please check data table here. Are you getting? Yes or no? Then you connect it to tree. Then you create tree. That a tree you connect it to test and score. Now you check. Now you check. Not working? Working? What was the problem? The confusion matrix is already there, no? We didn't do anything with the confusion matrix. Oh, you connected directly to output, huh? No, you do how I have done. Yes, yes. So test and score has now 2 algorithms. What are those algorithms? Logistic regression and tree, right? Now you see the result. Please see the result, all of you. Go to the confusion matrix and see the results and try to compare whether they are one and the same or there is a difference. Please see quickly, because we cannot do tit by now because this time is short. So you can just have a quick look how it has done, whether decisions have any better or more or less it's similar to logistic regression, right? Now what you need to do is that also you can see from the test and score. Please double click test and score. Please double click test and score, right? Double click test and score. Are you seeing this too? How many of you are able to see this particular screen? I think almost all of you. So can you now compare what is the area under the curve? Slightly better. Classification accuracy slightly better, at least 1% has increased. F1 score more or less similar. Precision has increased to some greater extent. Recall also has increased, and the correlation coefficient also has increased. So looks like, as madam said, the algorithm may also help sometimes. So in this case, the tree based decision is a little helping to have little incremental accuracy, right? Now let us try with 2 more or 3 more algorithms that I have already shown you. Now you connect it, same thing you connect with the naive based algorithm, support vector machine, and the other one is random forest. these 3 algorithms you please try to connect with the test and score and see whether you are able to see all the test result in one shot. Okay, let's see. Sorry, repeat once. Okay, fine. So is this clear? Is this clear? Now what I am saying is you have to connect with the navy based, connect, random forest, connect, right, support vector machine, connect here. So 1, 2 are already there, naive based, random forest and your SVM. Now 3 different machine learning algorithms we are trying to connect because we want better accuracy. If better accuracy can be given by other methods, not really by logistic regression and decision tree. That is our objective, because I am just going by madam's thought. So let us connect it. So type NAIVE, right, based on the conditional probability, connected. Are you able to connect? Naive based, then you connect random forest. Random forest is basically multiple decision trees and the average has been taken in single tree, right, to control the overfitting. There is something called overfitting and underfitting, right, that I will tell you little later when you go for the training and testing. So now you connect it. Done. So how many algorithms you have connected? Logistic regression, right, tree, naive based, random forest, one more, SVM. So SVM already available. So all the inputs have given to test and score. Now hopefully test and score must have been executing the result. Can you double click and see whether it is there? All the test results. Can you see? Of course, there is a small font. I think you can see in your own system. So area under the curve is the highest in which algorithm? Tree based algorithm is the highest. Both are highest. Then classification accuracy, same. Then that means whatever tree has given you here, that is more or less the best possible answer. So that means it might have taken the best possible answer to give you. But sometimes random forest may give you better accuracy than decision tree, because random forest is like, it's a logical situation where it has taken multiple decision trees and gives you the average of all those results, right? That is actually internal algorithm. So here it may be slightly different or maybe same, but it may be different in other cases. So now let's see precision, random forest, tree is again highest, recall, that is nothing but your true positive rate, that is this one and this one, they are the highest. Support vector machine could not give better result in this case, right? Normally support vector machine also gives you better result, but one problem with the support vector machine is it is a little difficult to interpret. There is a problem with the interpretation, though it may give sometimes better accuracy, but interpretation wise a little difficult, right? So that way we have to see, because after all it should lead to a managerial decision making. Of course, for many of your mathematical research, it may lead to a theoretical problem, but for us in management, we basically look for whether the solution is implementable solution or not, right? Otherwise, it will be completely a theoretical phenomenon that we actually don't want. We want something which is practical and we can take a decision, right? Anyway, so up to this part is clear. Up to this part is clear. Now you can see the confusion matrix. Please see the confusion matrix. So are you able to see the confusion matrix for all the learning algorithms? So one by one you can click and see. Now it is by default, it is click logistic regression. You click the second one, tree, naive based, random forest, SVM. You are able to see. These are the main algorithms that I have shown you here, right? Now that will be doing it. Okay, this part is clear. Is this part clear or not? So we did not do any splitting so far. Now let us do the splitting. You may need to little be faster, right? So up to this is clear. Any further queries or concern up to this? Let us go to the splitting part. Right? What is splitting part? What is splitting part? Splitting part, let me tell you, data, right? Data goes to two parts, training, and one goes to testing. Normally this is taken to be 80%, this is taken to be 20%. You build the model with this, right? After you build the model, then you pass this data through training to see the accuracy. This is a typical machine learning algorithm, right? Once again I repeat, please pay your attention because we need to complete on time. So you have the data, please understand logically how it happens. The machine is given only the data which is a subset of the entire data. Normally what percentage? 70% or 80%. There are, if you are doing some research on that, you have to find some literature source, some literature review supporting your argument. But normally in the business we take 80%, 20%, 80-20 rule according to the Pareto chart, right? So 80% of the data has been fed into the system for building the model. Then what about the 20% of the data? Those 20% of the data has not been taken into consideration for building the model. They have been kept aside in some memory. When you will be testing it, right, those data will be now coming to your model and giving you the accuracy. So this is exactly the typical machine learning algorithm. So testing data has not been used for the model building, right? Training data has been used for the model building. So there you have the flexibility, making it 70%, 75%, 80%. Then remaining data is the complement that will be used for the testing. So this is one part. Now second thing is that in case you want to compare the results of training data and the testing data, right? So you need to compare the accuracies of the training data and the testing data. Sometimes accuracy of the training data is higher than the accuracy of the testing data. That is basically called as a situation which is overfitting the model. Model overfitting. And if the vice versa takes place, we say model is underfitting. So to avoid underfitting, overfitting kind of situation, we need to exercise this particular thing. So this is one type of separating the data. There are two other types of separating the data. Before that, I'll just show you how you can really split the data and what are the ways for splitting the data. There are also two more ways. I'll just quickly show you. So this is actually the part of something called as cross validation. This is basically called as cross validation, right? So for cross validation, as you see, this is one way I have shown you, right? There are also other ways, that is called as repeating training testing data, that is 80%, 20%. You do it multiple times. You do it multiple times, right? Because the data is chosen at random. The data has been chosen at random. You don't see what data has been chosen at random, right? So when you choose it multiple times, the data have been chosen at random. Now the question comes here, how to take the data as the best model fit? Maybe you can take the average, or you can take the best model fit like the random forest, right? This is one way. The third way is called as k-fold cross validation. That means if you have 100 observation, you divide 100 observation by 10 parts, right? So how many each part will be having? 10, right? Now what you need to do, you use 9 folds or 9 different data set for your model building. One data set, that is with a 10 record, you keep for testing. So that means 9 by 10 you are using for building the model, 1 by 10 you are keeping for testing the model. That is called as k-fold cross validation. Certain times what happens, people also take something called leave one out cross validation, that is called as loose sieve. Loose sieve. What is loose sieve? Only one data point, one observation kept as testing data, rest of the data points will be taken as training data. So these are the various methods available for training and testing, right? Now without wasting on much time on this theoretical part, let us get into the orange software and find out how it actually works. Okay, so let us go there. So I take you through this. Okay, so let there be all the algorithms. Maybe all of you can save it in your system and copy in your pen drive or send it to your email, right? For afterwards, because once we go from the workshop, we normally forget certain things. it is a very friendly software. Without wasting much time on the Python coding, you can get your input. But the problem is, it is not very highly flexible. It doesn't give many things like p values, right? Then standard errors. It doesn't give many things. For that, again, you have to go to the Python, right? That's the one demerit of this particular software. Anyway, so broadly it is fine. Broadly it is fine. Now you take what is that I'm going to do? I want one change. What is the change? I want this data has been now into two parts, to be separated into two parts, right? So if I want to separate the data into two parts, what I'll do is I'll first remove this particular connection. Okay, so now there is no data support. You try now, nothing will come. You try in your analysis, now you will not be able to see anything because data is not there. So when data is not there, how it will execute? No algorithm will execute because there is no data. Now what I'm going to do, you take something called as data sampler. Data sampler. There is another widget called as data sampler. Data sampler will be telling you what exactly you want with respect to your analysis. Now you connect it to the file. File is the input to the data sampler. Now data sampler is the input to test and score, right? Now there are two types of data in the data sampler. What are those? One is training data, another one is testing data, right? So what I need to do is I can click on this particular connection or the arrow, then I can find two different types of things. Data sample is the data that is for the training, and remaining data is the testing. Just to connect, remaining data is equal to testing. This you are able to connect? Any difficulty? I can cancel it. Data is going to data, data sample is going to data, that is for the training, remaining data is going to testing. Simple. Then you press OK. Now what do you see? All of you please do it. Take 1 minute, complete it, then we'll proceed further. This is your entire data, Titanic data. This data has how many records? 2201 records into 0.8 coming to some figure. That figure is nothing but your training. The remaining is testing, right? So are you able to connect it first of all? How many of you are able to connect it? Some cases not able to connect. Able to connect? Okay, very good. So now what you see, there are two different connections. From data sampler to the test and score, there are two different connectors. What are those connectors? One is for the training, that is data sample. Other one is for the testing, that is called remaining data. That is also clearly mentioned here, remaining data, right? Now the question comes here, what percentage of the data you would like to keep for training? What percentage of the data you would like to keep for testing? So let us click data sampler, click on data sampler. I have fixed it to 80%, you also fix it to 80%, right? You also fix it to 80%, right? So what does this mean? That means 80% of the data will go through this particular algorithm, 20% of the data will not be used in any way, it will be saved somewhere in the memory in the system, right? Now the question comes, who are those 80%? It is a random selection. When you take a random selection, as you all know, that there is a probability working behind it. Everybody in the observation should have the equal chance to get selected. So there are 2201 things. So if you take 80%, roughly you will get 1700 or so, right? Or 1600 plus. So the probability of everybody is 1 by 1600 or 1700. So it is equally likely. Everybody should be getting equal chance. But normally in the business, we basically take convenient sampling, which is actually not very appropriate. In mathematics or the statistics, we actually should supposed to take random sampling. That is what exactly is happening here, right? Now let us close it. So sample data is 80%, close it. Now you can see there is a small icon here, triangle kind of icon created. So that means both the data are there in the test and score, right? So now you double click test and score and see what is that is really happening. Double click test and score. double click test and score. What do you see? There are two things here, training and testing. Now you click on testing, you should see the values, right? If the testing part is not working for you, then there is something wrong, we have to check it, right? Let's see, let us click it. I'm getting in both the cases, right? I'm getting in both the cases. Now you can see one thing, the comparison, right? You can see the comparison. So how can you see the comparison? How can you see the comparison? You can copy to the Word document or Excel file, then you can compare. Let us not do it here. So let us quickly cross check. Tree was the highest, okay? So what is the tree based algorithm has given us in this case? There's a tree, and the classification accuracy is equal to how much? 0.789. So 0.789. Now this is for what? Training. This is for training or testing? I'm sorry, this is for testing. This is for testing. Now similarly, what is that is for training? Please see. What is that you are getting? 0. That is tree. This is equal to testing, 0.791. This is for training. So what do you see in this case? What do you see in this case? They are very close, 0.79, and if you round it off to the nearest decimal with the 2 digit, so we are getting the same thing. So that means training and testing, they are going very close to each other. They are going very close to each other. What does this mean? That means the model is giving us the best fit result. There is no underfitting, there is no overfitting, right? Similarly, you take for one more algorithm, random forest. You see for random forest, what is that? Is the I've taken only one metric, one KPI. You can take also other things. Just you save it, right? Somewhere there will be saving. You save the file or they report it. You can go to this 3 dot if you want to take this file to somewhere. You can just see, click that 3 dot, then you will see file, then you see report, right? This report will be created, and this report you can save, right? You save this report, and for comparison, take them to the Excel sheet and compare, right? Because you should be now able to compare the training result and the testing result. Training result and the testing result. How many times you can do it? As many times as you want. 70%, 30% also you can check, right? Let's see 70%, 30% if there is any better, right? Let's see quickly. Yeah, yes, madam. So you just close it, go to our analysis, okay? So there you go for the test and score. You are able to see this. On your left hand side bottom, there is a 3-line bar, then go to file, then go to report. You should be able to see this, right? Then you save according to your interest, you just save it. So on the desktop, let's say analysis 1, right? That's fine. Analysis 1, something like that, it will be saved. So you can see analysis 1, right? I can open it, see this, right? For comparison, because sometimes we may need this to Excel sheet or to our Word document. So this is the way we can probably do this. So let me close now. So let us go to training and testing once again, right? By the way, everybody is able to see this now? Anywhere you are not able to execute, not able to see the analysis? Both for training and testing? Both for training and testing, right? That is the correct way of doing the things. Now go to your data sampler, and now you change it to 70% and 30%. Please remember, this is a case if you are into machine learning in your research or something, there is no standard rule for this, okay? Though 80%, 20% is mostly used, but for your research, you may have to have some literature evidence. some literature evidence people might have used it earlier, you may have to use it. Okay. Then you let us take 70% and 30%. Let's see what happens. Okay, that you can exercise. Sample data. So as you see, 1541 records have been used for training. 660, I believe it is 660. You can also drag it, I believe. It's not coming. So the remaining 660, right? Partly visible. 660 is for testing. So let's see now. Any change you are able to see? What is for the tree? How much you are getting as your classification accuracy? 78%, almost close to the previous case. What is for the testing data? Slightly more, 80%. What is your inference out of this? Slightly underfitting the model. The model is slightly underfitting. So better you can keep more data for training than testing, right? So that is what you can do. Similarly, you can do the other side also. Bring it to 90%, 10%. Let's see what happens. I'm not checking every single result because it will take a lot of time. Our time is also short. So let us do it for, go to data sampler, make it 90%, drag it, sample data. So that means what is the data used for training? 1981 records have been used for training and 220 is being used for testing. So let us close it. Then let's see. I'm taking one algorithm. Let us take tree. For tree, what is the accuracy? 79% for the testing data. For the training, what is the accuracy? Same. So almost same. That means there is no overfitting, there is no underfitting. So you can probably record, or you can probably report to in your research problem, or maybe report to the funding agencies. This is what is really happening. Let us say you are doing some healthcare analysis. You can probably report, but you may need more data, right? We have taken almost all the important algorithms, but unfortunately our accuracy is not going beyond 80%. We should get sometimes 90% or 95% accuracy. Why I am saying 95% accuracy? Because in the normal distribution, right, minus 2 sigma to plus 2 sigma, if you take, right, this gives 95% accuracy, right? And 95% accuracy is translating into 5% of error, and this 5% of error is basically taking you to 5%, that is 5 by 100, right? Then out of 1000 is 50, out of 10,000 is 500, right? Out of 1 million it is 5,000, out of 1 million it is 50,000. There are a lot of inaccuracies, right? Why I am doing this? Because in a country like India or China or any other populated country, so we have to see how far we are getting the accuracies, right? So if you take, this is nothing but your 1 million. So 1 million we are getting 50,000 inaccuracies, right? What does this mean? Let us say you are a pharmaceutical company, you have any medicine or injection like COVID-19 injections we have taken, right? So how many cases it worked and how many cases it didn't work, there is no proper report, right? So how many, many of us may be thinking, because of my confidence, because of my own, immunity, I might have come out of this particular problem, right? They may be correct also, right? Because whatever medicines we had in our country, their efficacy levels were less than 90%. Less than 90%. I am talking about 95%. None of the companies claimed 95% accuracy, right? Including Pfizer. Pfizer could not be transported to India because of various logistics issues. Because of the cold storage and all that issues, we could not have it. We had only Covaxin and Covishield. They had less than 90% accuracy. And you can imagine, if you take 90%, that is somewhere you can see minus 1.96, minus 1.645 to plus 1.645, right? That will be giving you 90%. So 10% is error. So then you can see the error part, right? So this is not at all a very good model. I'm talking about it from model perspective, so it is not a very good model. So we have to have more data on this particular part, right? Because we need at least 95% accuracy. But all our models have given less than 80% accuracy. So then question comes, we have used all the sophisticated models. We have used all the sophisticated models. Despite that, why our models did not give the better accuracy? So then you may have to have more data. So machine learning is basically a method where you need more data. Higher is the data size, better is the accuracy, right? But the problem is actually sometimes, if you take time series data, right, time series data, so there actually we may not be able to, what's the problem? Fine. So certain times for the time series data, there are some restrictions with respect to the prediction. Is there anyone who is working with respect to prediction? No? Maybe your area of research is completely different. We basically in the business, we do predict with the time series data, right? We used panel regression, then auto-regressive integrated moving average method, ARIMA, then seasonal ARIMA, all those kind of stuff we use. But some of your case you may not be using it. But anyway, in case you are into machine learning research paper or something, you can probably use all the good algorithms you have taken into consideration, right? But despite that, our model has not given us good results. So what could be the issue? The issue could be related to your data size, right? Now, can you try with two other cross validation criteria? What are the two other cross validation criteria we have discussed? K-fold. Go for the K-fold and see what happens. Let us go for K-fold. So data sampler, then you go test and score. Let us say leave one out. It may take a lot of time, right? It takes a lot of time because it is 1%, right? I am quickly getting into K-fold. What is K-fold? Cross validation. It takes a lot of time. I believe you have done it earlier. That's a good thing. So K-fold means it may take less time than the leave one out, that loosey part, right? So we have divided the data into 10 parts. Now let us see the result, right? So what is the tree result? 0.79. What is the test result? 0.79. No change. There is no change. If you want to fold 20 parts, can you do it? Can you do it 20 parts if you fold? What is the record? 2201 divided by 10 divided by 20. Every fold will have 100 records. Sorry, 2200 divided by 20. 100 records more or less. 120 records, right? So you'll get that record. Then 9 times you use for your model. Now you say how it is happening. It is actually happening in the algorithm. You do not have to manually do anything. So that part if you do, then let us see whether it is going to change 20 times, right? So as you see here, the data has been divided into 20 parts, right? 20 parts. 20, if you take 20, then 95% of the 20, right? 20 parts have been divided. So now 90% of this. So how many have been taken for your, let us see, this part, 20 folds, right? Then, so you can see now 1981 instances, okay? 1901 instances have been taken to be 1981 divided by 2201 is how much? Greater than 90%, I think, right? 90%. So 90% have been used for training, the rest has been used for testing. Yes or no? Right? So 5 means features, right? So here you have 1981. So that means the data have been given into or divided into 20 parts, right? So this is taken for training, the remaining has been used for testing. So this is one thing that you have to see. But please see whether there is any change in the result. Tree, let's say tree, right? This is the one, right? 0.91, right? Then if you see for this is for training, right? Here it is given 1981 and 220, right? So if you do that cross validation part, so hopefully it is given here. So this part is cross validation 20 parts. So if I want to see the test, is it the same as previous? That is what I am saying. This is cross validation. So we should have two different sets, no? We should have two different sets. Okay. So these many features have been used for this. But how can you see the testing part? Just click it here and see. Training time, testing time, that's all fine. So in this case, what is happening? Only one result is given here. This is again random sampling, right? Training size it will giving, but when you are checking these two, it is taking us to the previous data sampler. Okay. One idea is here. I don't know. There is that particular feature also should have been there, right? So number of folds is this training feature, training and testing, like how it is given here, right? So that way it has maybe some limitation. Then what you can do is in the data sampler you can divide it one to data size, that is let us say 80%, okay, then another one is 20%, both can be connected to the test and score, then you check whether it is giving you two different results. When you are checking your, I think you can go, this is one result, right? No, here you can check, no, I think it is not giving. So like here training and testing we have seen, right? Here we should have also training and testing, right? Maybe that feature is not available, I'm not sure, you can probably check, I'll also check, right? So that is actually, these are the few ways. Let us see, leave one out. Again here it may take slightly long time as you said, right? Because it has to leave one observation for the testing and the remaining observation, that is 99% for the training, right? So that way it may have, you know, little more kind of estimation time, because only one observation you are keeping for testing and the remaining for training. So when I am clicking this, it is taking to the previous case. So that is one thing. So I don't know, hopefully you know, training and testing should have been available here also, right? Maybe some other, you know, I think it is the latest one. This is the latest software, right? So then probably you can try with data sampler. You divide it 80%, right? 80% you take for the training, then 20% take for testing, and both the things you connect it to the is taking some time to connect it to test and score, and run it and see if this is working, right? So that is one limitation I found actually. I didn't trace it so far, but this and this is taking with respect to 80%, 20%, right? Then this is also one thing, but I don't know whether we'll be seeing the training result. We'll be seeing the training result, but what about the testing result for the comparison? That also you need to have to see. So it is taking some time. Anybody executed? I was expecting it should be available here at least here, training and testing, but only training is visible. Sorry? Yes, running. Maybe you click on training and testing and see whether it is giving you something. If you have executed for K-fold, just click on training and click on testing. Just see whether it is giving you different result. Maybe let us drop this leave one out for the time being. I'm clicking again on the K-fold. So this is what is my result with respect to all the methods. If I see, go to the report, let us see if report it is there. It is only training results, okay? Not there. So is it giving? Just have a look at it. I think it is there. Here you can click. I thought it is time. So just see whether results are different. See the training results. It's a tree, 79%. For test, no, that may be there, but we need to see now. For a comparison, we need to see, right? We need to see training and testing. So click on train. No, you just click it there and see whether they are different. Training result and the testing result, are they different? I believe it is different only. See, for tree 79%, right? For test 75%. Yes, it is there. Are you able to see? No. But I need to see the test result also, no? But I think, no, that's fine. But figures are different, right? It is time, no? Evaluation result for the target. So then we have to only see that training result, okay? So for the testing result, maybe again for the data sampler, you divide into two data set, one for 80%, one for 20%, and you pass through, the test and score. Maybe something like this. The data sampler, right? So then what you can do is maybe data is here, right? But it will be one and the same, no? 80% is going here, data is going here, right? Then for test, if you create one more table also, let's see, data sampler here, this is remaining data, okay, right? So training is going here, testing has come here, right? Now for the test, let us say test and score. Please see. No. Random sampling. 80% here. So this is not the right way. So this is actually here you have to connect this right way. You can check once how to get that test result for what is that k-fold cross validation. Okay, so let us stop here because I don't want to get into more time. So here right, so we have come back to our earlier, so that is 80%, 20%, and for k-fold we have seen the training, but test result we are not able to see. Maybe there's a limitation also, we have to check, right? I'm not very sure, so you can check it, right? So I think we're on time, so we'll stop here. This particular thing I think all of you might have done, right? You just save it, then take it into your what is that email or maybe pen drive, right? So this should help, right? And there are some features available for distribution, for you know, for some basic statistics also you can do. I have not done because of paucity of the time, right? So that's all about it. So thank you very much. And if there is anything, I have my email ID in the presentation, right? And please connect through email ID or maybe through LinkedIn, wherever, right? And any queries further, we'll just see, right? So thank you very much. Uh,
Thank you very much. Good afternoon. Sorry for the delay. So, which language you prefer? Telugu or English or Hindi? Huh? Telugu? Huh? Multi-language. Okay. Andhra kada. So, it's easy for me. So, I will move English and Telugu both. Huh? So, that will be easy for me. I am basically from Ongole only. So, from Andhra. So, but I, huh? మీరు కూడానా నెల్లూరు ఓకే యా నేను ఆంధ్ర మొత్తం చదువుకుంటూ తిరుగుతున్నాను కాబట్టి నా స్లాంగ్ అంతా డిఫరెంట్గా ఉంటుంది. కొన్నాళ్ళు రాయలసీమలో ఉన్నాను, కొన్నాళ్ళు రాజమండ్రిలో చదివాను. సో ఇట్స్ ఎ మిక్స్డ్ స్లాంగ్. ఆ తర్వాత అబ్రాడ్ వెళ్ళొచ్చాను కాబట్టి కంప్లీట్గా మారిపోతుంది. ఇక్కడికి 2003లో వచ్చాను, నేను 23లో వచ్చాను ఇక్కడికి. బిఫోర్ దట్ ఐ వాజ్ ఇన్ పూణే. I was teaching for MSc Atmospheric Science and MTech Atmospheric Science. So basically we, in the atmospheric science, it comes under a Earth Science division. In the, you know, everyday daily life we are seeing weather, how weather is changing. So we teach the students how weather get affected on a physical sense, not only just by seeing how the wind is changing or temperature is changing. What are the cause? What are the, is it a natural cause or is it a kind of a man-made cause? We do all kind of studies, and then we discuss with the student, we teach the students what are the dynamics that controls your earth atmosphere. So it, when we talk about the atmosphere, we feel like atmosphere is only up to 10 kilometers, but it is not true. The atmosphere is extended to up to hundreds of kilometers. Till 100 kilometers we have the atmospheric gases. After that we have the ionization gas. So any change in that is happening in the ground will be reflecting in all levels of the atmosphere. You can see in around 100 kilometers also. Sometimes you can see in the 600 kilometers, we call it as F region, where we won't see in terms of the temperature, there we see in terms of ionization. Okay. So whatever we learn, now I'm going to show you some kind of a trend analysis, how the trends are moving. So these, you can use the ionospheric data as well. But unfortunately, we don't have so much data. Luckily, we have a data in the ground, surface level. Our ancestors, they collected data from 1800. So from 1800 to till now, we have a continuous data. This is one of the website, GIS surface temperature analysis. Because when we talk anything, we feel we talk in terms of the some parameter. The weather is very hot or cold, so or maybe it is a normal temperature. So this temperature is provides is one of the climatic variability. Temperature is one of the climatic variability. So in the we have a lot of observatories. They measure continuously this temperature. They measure every 1 second, but they accumulate it daily average and then monthly average. And from the monthly, they will try to see how it is varying, whether the temperatures are going increasing or decreasing. Here there is two concepts comes. When I am talking about a weather means it is a localized scale. It's about 1 week or 2 weeks or maybe 1 month or maybe evening hours, maybe morning, next few hours, what going to be the weather. But there is another concept we called as a climate. Climate, we cannot, all the time we say like a climate is not good. ఒకరోజు సడన్గా ఎండగా వస్తుంది చూసి బయట క్లైమేట్ బాగలేదంటాం, బట్ ఇట్స్ నాట్ ద కరెక్ట్ వర్డ్ టు యూజ్ ఇట్. వెదర్ ఈజ్ నాట్ గుడ్, వాతావరణం బాగాలేదని చెప్తాం. వెదర్ వీ హ్యావ్ టు టాక్ ఇన్ టర్మ్స్ ఆఫ్ ద వెదర్, బట్ హియర్ వీ ఆల్వేస్ యూజ్ ద క్లైమేట్. Climate means its average over 30 years. Over a 30 years, if you average it and then see how over 30 years above how weather it is changing or decreasing, it going up or down, that accordingly we can say there's a trend in it. So here the data, whatever we showing here, this contains data from, let's assume this one is, I guess, Okay, here they consider 1951 to 1980 as the baseline. 30 years of data, they average. From the baseline, they were trying to see whether the temperature trends are increasing or decreasing. Okay, why they gone for 1951 to 1980 is because industrial era. Because of the industrial era, we have a lot of anthropogenic gases are increasing. That is CO2, carbon dioxide, carbon monoxide, nitrous oxide. A lot of things are increasing in the atmosphere, which raises the temperature like anything. So to address that one, we gone for the early era. Okay, from this one we are taking considering, but the data is available from 1882 till present date. Okay, the time series available from 1882 till now, and then they are, this mean value will be subtracted from the individual month data, and then you will get the anomaly. And then by seeing that anomaly, we can say whether the temperatures are decreasing or increasing. Okay, in our lab course, they said like there is a one tool we are going to use. It's called a Looker Studio. Google provide you a Looker Studio. We're going to use that one. I guess you have access for it. It's a free one, but the only thing is you have to sign in for it. I'll show you first what we have to do, and then we'll go. Here, few more topics here. This data here is given global monthly. That means entire globe they averaged. Second one is only northern hemisphere, only southern hemisphere. So third one, last one will be the zonal mean. Zonal mean means and the longitude values it will be averaged. So you will get all latitudes information. Okay, here complete globe, only northern hemisphere, southern hemisphere, now individual everyone. So I'm going to show you how the data looks like for this one. You can try for this. Okay. So first of all, let's download the data. Are you able to see the data? Okay. Here the data is given January to December, and then they average for January to December, December to November, DJF. It's a season wise. Different seasons they average. I'm going to take only monthly means. You forget about this one. Okay. So we have to import this data into our Looker Studio. Okay. We'll go for the Looker Studio. You can please open in your PC. Yeah. Basically, this Looker Studio is meant for the Facebook and all these people, like software guys, not for or this kind of data analysis. So they will be having a date stamp, correct time series. We also have the time series, but we won't maintain such kind of a date stamp. So it's a little bit tricky here. That's why I'm showing from the starting. I'll take another file also. How to recover that one. So please go through the GIS one, download CSV file, this one. Okay, this is the file. Wait a minute, let me do it. Yeah. Okay, if you already signed in, give access to Google, then you will get this information. You have to go here to the create. When you click that create, there will be a 3 options: export, data source and explorer. First we have to upload our data source because it is not available directly. We have to upload our data source. So there is a connector. Whatever the data we have, we are going to give to the studio. Going to upload it online. To upload that one, there are connectors. Few connectors are from the Google itself, or few from the some other companies. So these are partner connectors. So here we are not, don't need to worry about all this. What we're going to do is we're going with the CSV file upload. Please click on that. Okay. Go to Google connectors, CSV file upload, CSV file upload, and then click on add file. Okay, I'll go back again. Okay, I'm repeating. Go to the create, click on data source, and then go to CSV file upload, click on add file, and then select the file, which one which you have downloaded already. ఇంత ముందు డౌన్లోడ్ చేసిన ఫైల్ని సెలెక్ట్ చేసుకోండి ఒకసారి. Yeah, that's why. Huh? Oh, you already tried this one. Okay. Okay. This error came because we required only one header. If you go with multiple headers, it won't work. So please remove the first one, land, sea, ocean, first one is there now, that you remove, that row, and then go down. Maybe here also 1880, there is some data gaps are there. Huh? You have to download it from website ఇక్కడ ఉంది కదా, GISS. బాగున్నావా? ఎర్రర్ వస్తుంది. అది కూడా కాదు, ఇంకా నేను వేరే ఫైల్ ఇస్తాను మీకు. CSV మీరు గూగుల్లో పెట్టుకుని సరిపోతుంది, డ్రైవ్లో పెట్టుకుని సరిపోతుంది. కానీ అక్కడ కూడా రాదు, దాన్ని వేరే ఫార్మాట్లోకి మార్చాలి. నేను ఎందుకంటే మళ్ళీ గబాల్న డంప్ చేసుకుంటారని ఆ ప్రాబ్లమ్స్ అన్నీ చెప్తున్నాను. ఒకసారి నేను ఒక ట్రై చేసి చివరికి నాకు ఫైనల్గా సొల్యూషన్ ఇస్తుంది. Global mean surface temperature. This one. Yeah, you can upload. But the only problem will be it has to be compatible with your Looker Studio. Now whatever you are going to upload now, none of these files will be useful for us. We're going to change that file into different format. I'll tell you how to do that one also. డౌన్లోడ్ అయిందా మీకు డేటా? దిస్ వన్ CSV ఫైల్. ఓకే, డౌన్లోడ్ అయిందా? ఒకసారి డౌన్లోడ్ అయిన తర్వాత ఈ డేటాలోకి వెళ్తే మీకు ఇక్కడ 2 ఉంటాయి, 2 ఉన్నాయి. ఫస్ట్ వన్ డిలీట్ చేయండి. ఇయర్ కాదు, ఇయర్ ముందు ఒకటి ఉంది కాలం. మీరు ఓపెన్ చేసే ఫైలు ఇలా వస్తుంది, ల్యాండ్ ఓషన్ గ్లోబల్ మీన్స్ అని వస్తుంది. ఆ రో మొత్తం delete చేయండి. ఒక్క హెడర్ మాత్రమే ఉండాలి మనకి ఇక్కడ. ఎర్రర్ కాదు, ఉన్నాయి ఇంకా ప్రాబ్లం. మరి ట్రై చేయండి ఒకసారి, డిలీట్ చేసిన తర్వాత ఒకసారి ట్రై చేయండి. మళ్ళీ ఎర్రర్ వచ్చింది కదా, అది తీసిన రాదు. చూడండి ఎర్రర్ వచ్చింది, చూడండి. మాకు ఎర్రర్ వచ్చింది, మీకు ఎట్లా వచ్చింది మళ్ళీ? లెఫ్ట్ సైడ్ పాతవే. ఓకే, సో ఇక్కడ ఒక చిన్న ప్రాబ్లం ఉంది. మీకు అప్లోడ్ అయితే ఓకే, అప్లోడ్ కాకపోయినా డోంట్ వరీ. ఈ డేటాని లూకర్ స్టూడియో తీసుకోండి. మీరు ప్లాట్ చేసేటప్పుడు ఎర్రర్ చూపిస్తుంది. లూకర్ స్టూడియోలో అది వేరే ఫార్మాట్లో ఉండాలి. ఆ అట్మాస్ఫియరిక్ సైన్స్లో వచ్చినప్పుడు ఏమవుతుందంటే మాకు మిగతా ప్లాటింగ్ కోడ్స్ కన్నిటికి సంబంధించి ఈ ఫార్మాట్లో వాడతాము. లూకర్ స్టూడియోలో డేట్ స్టాంప్ అని సపరేట్గా పెడతారు, అది లాంగ్ వేలో ఉండాలన్నాడు. సో మీరు ఏం చేస్తారంటే, మీకు చాట్ జీపీటీ కానీ జెమినై కానీ యాక్సెస్ ఉందా? ఒకసారి ఓపెన్ చేయండి జెమినై ఆర్ చాట్ జీపీటీ. ఈ ఫైల్ని లూకర్ స్టూడియో జెమినైలో కానీ చాట్ జీపీటీలో కానీ అప్లోడ్ చేసి కన్వర్ట్ ఇంటూ లూకర్ స్టూడియో కంపాటబుల్ ఫైల్ ఫార్మాట్. Convert the file into Looker Studio compatible file. చేశారా? డైరెక్ట్ చేశారు? ఓకే, చూడండి వస్తుందేమో చూడండి. Convert the file into Looker Studio compatible. చేస్తే ఇలా లాంగ్ ఫార్మాట్లో వస్తుంది. ఇందాక మీకు డేటా హారిజంటల్గా అరేంజ్ చేస్తుంది కదా, ఇది ఇలా అరేంజ్ చేస్తుంది. సేమ్ ఫార్మాటే, సేమ్ డేటానే, కాకపోతే అరేంజ్ చేయడం డిఫరెంట్గా చేస్తుంది. యా, డిఫరెంట్ ఇయర్స్, జనవరి అనామలీ వస్తుంది, దెన్ ఆల్ ఇయర్స్ వస్తుంది, ఫిబ్రవరి. మీకు అప్లోడ్ అయితే పర్లేదు, అప్లోడ్ కాకపోతే ఇలా చేసి వచ్చిన ఫైల్ని అప్లోడ్ చేసుకోండి. మీరు చెప్పారు లూకర్ స్టూడియో గురించి? ఎవరు? నేను ఫస్ట్ అడిగినప్పుడు ఏదైనా టూల్ ఓకే అన్నారు. ఇది కొత్తగా ఉందని ట్రై చేశాను. ఎన్ని రోజులు ఇది FDP? 5 days. 3rd. ఏమొచ్చిందండి? సరే, అయితే మీకు ఏమైనా వాట్సాప్ గ్రూప్ ఏమైనా ఉందా? సరే, నన్ను యాడ్ చేయండి వాట్సాప్లో, దాంట్లో లోడ్ చేస్తాను. నీకు పంపించిన మొత్తం షేర్ చేయండి. నాగేంద్ర కుమార్ ఎక్కడి నుంచి? కంప్యూటర్ సైన్స్. ఏం చెప్పారు? గూగుల్ లుక్ మేక్ సెన్స్. దేని గురించి అది? ఆహా, ఓకే. రోబో ఫ్లూ అన్నీ కొత్త కొత్త వస్తున్నాయి. వాట్సాప్లో పంపించానండి. మీకు వచ్చిందా? మీకు డౌన్లోడ్ అయిందా? అప్లోడ్ అయిందా? వాట్సాప్లో పంపించండి, చెక్ చేసుకోండి ఒకసారి. ఒకసారి అప్లోడ్ అయిన తర్వాత ఎర్రర్ చూపిస్తుందా? ఎందుకని చూడండి, సిఎస్వి ఫైల్ తీసుకున్నారు, లేకపోతే ఎక్స్టెన్షన్ వాట్సాప్లో నుంచి వచ్చినప్పుడు డాట్ ఎక్స్టెన్షన్ పోతుంది, ఒకసారి చెక్ చేసుకోండి. ఓకే, మీరు అది అప్లోడ్ చేసిన తర్వాత మీకు ఎనామలీ మంత్ నెంబరు ఇయర్ అని వస్తుంది. దాని కింద రికార్డ్ కౌంట్ అవి వస్తుంది. బట్ ఇది మాత్రం సఫిషియెంట్ కాదు మనకి. ఇక్కడ ఏం చేయాలంటే మనము డేటా డే నెంబర్ ఒకటి తీసుకోవాల్సి ఉంటుంది. దానికోసమని ఏం చేస్తారంటే మీరు యాడ్ ఫీల్డ్ అని కొట్టండి. యాడ్, click on add a field, add calculated field. ఓకే, సో మీరు అప్లోడ్ చేసిన తర్వాత మీకు ఎనామలీ మంత్ నెంబరు ఇయర్ వస్తాయి. మీ దాంట్లో క్లైమేట్ ఇయర్ లేదు, దాంట్లో నేను అది క్రియేట్ చేస్తున్నాను. సో మీరు ఏం చేయాలంటే అది క్రియేట్ చేయాలంటే యాడ్ ఏ ఫీల్డ్ క్లిక్ చేయండి. క్లిక్ యాడ్ ఏ ఫీల్డ్. ఇయర్, టెంపరేచర్ వచ్చిందా? ఒక్క నిమిషం. కూర్చోండి. దాని మీద క్లిక్ చేయండి. అది ఓకే, యాడ్ ఫైల్ క్లిక్ చేయండి. క్యాన్సిల్ దీని మీద క్లిక్ చేయండి. క్లిక్ చేయండి. కనెక్ట్. వెయిట్, అది మళ్ళీ చూద్దరు. ఓకే, మళ్ళీ ఫస్ట్ నుంచి వెళ్తున్నాను. క్రియేట్ డేటా సోర్స్. ఏదైనా పాయింట్ మిస్ అయితే చూసుకోండి. మళ్ళీ CSV ఫైల్ అప్లోడ్, యాడ్ లాంగ్ ఫార్మాట్. నేను ఏదైతే పంపించాను అది. ఒకసారి అది అప్లోడ్ అయిన తర్వాత ఇక్కడ కనెక్ట్ అని క్లిక్ చేయండి. పైన కనెక్ట్ కనబడుతుందా? దాని మీద క్లిక్ చేయండి. ఓకే, ఇవి వచ్చినాయి మీకు కనెక్ట్ చేయకూడదు. మీకు ఒక పాపప్ మెనూ కూడా వస్తుంది, యాడ్ టు రిపోర్ట్ అని. అది క్యాన్సిల్ చేయండి. అక్కడ క్లిక్ కొట్టేస్తే అది పక్కకి వెళ్ళిపోతుంది. ఇది ఇక్కడ యాడ్ చేయాల్సింది ఉంది మనం, లేదంటే అక్కడికైనా వెళ్ళి చేయొచ్చు, ప్రాబ్లం లేదు. సో ఇప్పుడు మనకి ఇక్కడ యాడ్ చేయాల్సింది డేట్ స్టాంప్ ఒకటి కావాలి. ఇప్పుడు ఇది చూస్తే ఎనామలీ అనేది నెంబరు, మంత్ అనేది ఇలా టెక్స్ట్లో ఉంది, మంత్ నెంబర్ కూడా నెంబరు, ఇయర్ నెంబరు, తర్వాత రికార్డ్ కౌంట్ అని ఉంటుంది. ఇవన్నీ ఓన్లీ పైన మెనూ చూపిస్తుంది. మీకు దాని యొక్క ప్రివ్యూ కావాలనుకుంటే ఇక్కడ డేటా ప్రివ్యూ మీద క్లిక్ చేయండి. ఎనామలీ సెలెక్ట్ చేసుకోండి. సో డేటా మొత్తం మీకు కనబడుతుంది. సేమ్ అదే మళ్ళీ ఇయర్ కూడా సెలెక్ట్ చేసుకొని చూసుకోండి. రెండు కనిపిస్తున్నాయి, రెండు కాలమ్స్ కనిపిస్తున్నాయి. కావాలంటే మొత్తం అన్ని క్లిక్ చేసుకున్నా మీ ఫైల్ మొత్తం యాడ్ చేసినంత కనబడుతుంది మీకు. కాకపోతే ఇది ర్యాండమ్గా కనిపిస్తుంది. ఇక్కడ మనం షార్ట్ చేస్తాం తర్వాత. ఓకే, ఇక్కడ మనం సరే ఆల్ ఫీల్డ్లోకి వెళ్ళండి. మళ్ళీ ఇక్కడికి వెళ్ళి యాడ్ ఏ ఫీల్డ్ అని క్లిక్ చేసి యాడ్ ఏ ఫీల్డ్, యాడ్ క్యాలిక్యులేటెడ్ ఫీల్డ్. ఇది ఒక నెంబర్ ఇవ్వండి. నేను డేట్ అని ఇస్తున్నాను. ఒక్క నిమిషం చెప్తాను. యాడ్ ఫీల్డ్, యాడ్ క్యాలిక్యులేటెడ్ ఫీల్డ్. ఏదో ఒక వేరియబుల్ ఇవ్వండి ఇక్కడ. దెన్ ఈ కమాండ్స్ ఎంటర్ చేసుకోండి. మీ ఇష్టం, ఇదంతా మీ చాయిస్. ఐడి, ఫీల్డ్ ఐడి కూడా మీరు మార్చుకోవచ్చు, ప్రాబ్లం లేదు. ఇక్కడ ఇయర్ అనే వేరియబుల్ ఉంది కదా మన కిందాక, అదే ఇక్కడ తీసుకుంటాము. దాన్ని స్ట్రింగ్గా తీసుకుంటుంది. దాంతోపాటు 0101ని కంకాట్ చేస్తుంది. అప్పుడు ఒక టైం స్టాంపు క్రియేట్ అవుతుంది. మనం ఇందాక డేటా చూస్తే 1881 అలా ఉంది. ఇప్పుడు ఇది చేయటం వల్ల ఏమవుతుందంటే 1881 కాస్త ఇలా మారుతుంది. దట్ మీన్స్ January 1st, 1881 అని. అది మీరు టైం కావాలనుకుంటే అది వాడే ఇస్తాడు. ఆ ఫార్ములాస్ ఇవన్నీ మీరు దాంట్లో బ్యాక్ ఎండ్లో నేర్చుకోవాలి. సింటాక్స్ యాక్చువల్గా బేసిక్గా మనం ఏం చేస్తున్నామంటే డేట్ స్టాంప్ని క్రియేట్ చేస్తున్నాం ఉన్న దాని నుంచి. ఇక్కడ డేట్ అని ఇవ్వచ్చు, డేట్ ఇచ్చేసి ఇయర్ 1,1 అని ఇవ్వచ్చు. కాకపోతే అది అన్ని చోట్ల పనిచేయట్లేదు. సో అందుకనే ప్యారెస్ డేట్ అని ఇచ్చి ఇక్కడ కంకార్డినేషన్ చేస్తున్నా. కంకార్డినేట్ క్యాస్ట్ ఇయర్ యాజ్ ఎ స్ట్రింగ్ అంటున్నాను. ఇయర్ని స్ట్రింగ్గా తీసుకోమంటున్నాను. 001 కూడా స్ట్రింగ్. అవి రెండు యాడ్ అయిపోయి మీకు అలా నెంబర్ క్రియేట్ అవుతుంది. హైఫన్ రాలేదని చూడండి సార్, చూడండి సార్, చూద్దాం. మీరు ఒకసారి సేవ్ చేసిన తర్వాత ఏమవుతుందో చూద్దాం. డేటా ఫార్మేట్ని మీరు మార్చుకోవచ్చు కూడా. ఇక్కడ మీరు ఇట్లా ఎలా ఇచ్చారో అలా వస్తుంది. ఇది వై అంటే వైవై ఫార్మేట్, ఇది మంత్ ఫార్మేట్, ఎంఎం ఫార్మేటు, ఇది డిడి ఫార్మేట్. ఓకే, ఇది అయిన తర్వాత మీరు కిందకి వెళ్ళి సేవ్ క్లిక్ చేయండి. అయిపోయిన తర్వాత సేవ్ క్లిక్ చేసి గో బ్యాక్ టు ఆల్ ఫీల్డ్స్. ఇక్కడ మీకు వచ్చేసింది చూడండి, ఆల్రెడీ డివై వచ్చేసింది. ఐ మీన్ డివై నేను డివై డేటా ప్రివ్యూలోకి వెళ్ళిపోయి డివైని సెలెక్ట్ చేసుకుంటే సో ఒక్కొక్కసారి మీకు ఆ డేటా ప్రివ్యూ వస్తుంది, ఒక్కొక్కసారి డేటా ప్రివ్యూ రాదు, ఎర్రర్ చూపిస్తుంది. ఓకే, డోంట్ వరీ, అది వెనక పక్క రన్ చేస్తుండదు, అది సిస్టమ్ ప్రాబ్లం, మనకు సంబంధం లేదు. ఇది ఓకే. గౌతమ్, చెప్పండి. 9494154394. మీరు ఒకసారి హాయ్ కొట్టండి. నా నెంబర్ రాలేదు కదా మీ దగ్గరికి. ఓకే, ఒకసారి నెంబర్ చెప్పండి మళ్ళీ. 9494 9494 154394. పంపించండి, షేర్ చేసుకోండి. సో ఇది అయిపోతే ఇప్పుడు మనం డేట్ స్టాంప్ క్రియేట్ చేస్తున్నాము. ఓకే, కంటిన్యూ చేయొచ్చా? ఓకే, అంతా అయిపోయిన తర్వాత క్రియేట్ రిపోర్ట్ మీద క్లిక్ చేయండి. క్లిక్ ఆన్ క్రియేట్ రిపోర్ట్. ఓకే, what is it saying? Error is coming, na? No, there will be. Okay, dismiss. That's what I'm saying. Sometimes it won't show. ఇది సేవ్ చేయండి. చేశారా? ఆల్ ఫీల్డ్లో చూడండి, ఒకసారి చెక్ చేయండి. ఏదది మీరు ఏం పెట్టారు? అది పెట్టారా? అలా పెట్టకండి. కనెక్ట్ చేయాలి, రీకనెక్ట్ చేయాలి. కంటిన్యూ. రివ్యూలోకి వెళ్ళండి, సెలెక్ట్ చేసుకోండి, రీఫ్రెష్ పెట్టండి. ఓకేనా? అది తీసేసాను, పేరు పెట్టుకోండి, దాన్ని ఈజీగా ఉంటుంది. మీకా మీరు డేటా మీద క్లిక్ చేయండి చెప్పారు, క్లిక్ చేయండి. ఓకే, మీరు డేటా సోర్స్లో ఉన్నారు కాబట్టి రావట్లేదు, మీరు రిపోర్ట్లోకి వెళ్ళిపోయారు ఆల్రెడీ. ఓకే, పర్లేదు. ఇక్కడ క్లిక్ చేయండి. ఓకే, ఆల్ కిందకి రండి. డిస్ప్లే మీకు డిస్ప్లే వస్తుంది. సెలెక్ట్ చేసుకోండి. కింద 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 వచ్చింది. Can you go to the data preview? Data preview, down. ఇక్కడ ఉంటుంది. ఒకసారి సెలెక్ట్ చేయండి D1. దాంతోపాటు ఇంకోటి ఏదైనా సెలెక్ట్ చేయండి. రిఫ్రెష్. ఇక అది సెలెక్ట్ D1 ఏదో తప్పు ఉంది, ఫార్ములా తప్పు రాశారు. ఇదేమైంది, చాలా వస్తుంది. చూసుకోండి. మీరు అంతకుముందు వాడారా అవన్నీ? సిటీ డేట్ అవన్నీ ఎక్కడి నుంచి వస్తుంది? ఏ ఫైల్ అప్లోడ్ చేస్తారు మీరు? ఆ ఇయర్ ఏముంది, ఆ ఇయర్ అక్కడ అందుకని రాలేదు. ఆ ఇయర్ వేరియబుల్ కదా, ఆ ఇయర్ ఇది మీరు నిరిచ్చిన డేటా కాదు ఇది. మీరు వేరే డేటాతో వాడుతున్నారు అందుకని. ఇది ఒకసారి ఎందుకు తేడా వస్తుంది? ఒకసారి బయట ఓపెన్ చేయండి ఫైల్. బయట ఫైల్ ఓపెన్ చేయండి. మీకు ఏదో ప్రాబ్లం. ఒకసారి మినిమైజ్ చేసి డెస్క్టాప్ మెసేజ్ చేస్తారా? ఇది ఎక్కడుంది? మీరు డౌన్లోడ్ చేస్తారు ఇక్కడ. రైట్ క్లిక్ ఇవ్వండి, ప్రాపర్టీస్కి వెళ్ళండి, కింద పెట్టండి. కరెక్ట్గానే ఉన్నాయి మరి, ఎందుకున్నారు కదా? లేదు, మీరు వేరే ఫైల్ వెళ్ళిపోతుంది. ఒకసారి ఈ ఫైల్ క్లోజ్ చేసేయండి. బయట క్లోజ్ చేయండి ఈ ఫైల్ని. క్లోజ్ చేయండి. ఇప్పుడు అప్లోడ్ చేయండి. ఒక్క నిమిషం సెలెక్ట్ చేయండి. అక్కడ పేరు రాయండి, ఏదన్నా డేటా ఏదో ఒకటి రాయండి. ట్రెండ్స్ అని లేకపోతే ఏదో ఒకటి. కంటిన్యూ అండి. ఓకే, ఇక్కడ అయిపోయింది చూడండి. ఓకే, గట్ ఇట్. ఓకే, యాడ్ టు రిపోర్ట్ క్లిక్ చేయండి. దెన్ ఇక్కడికి వెళ్తే మీకు ఇక్కడ మీరు ఏదో ఒక పేరు పెట్టుకోవచ్చు. ఇది వచ్చేసి డాష్ బోర్డ్. ఇట్ క్రియేట్స్ ఎ డాష్ బోర్డ్ అనమాట. సో మీరు ఫైల్కి నేమ్ చేంజ్ చేసుకోండి. ఇక్కడ అన్టైటిల్డ్ అని వస్తుంది. ఫస్ట్ మీరు సెలెక్ట్ చేసుకొని ఫైల్ నేమ్ చేంజ్ చేసుకోండి. ల్యాబ్ 11/03/2026. చేసిన తర్వాత ఇక్కడ థీమ్ అండ్ లేఅవుట్ అని ఉంటుంది చూడండి. సెలెక్ట్ థీమ్ అండ్ లేఅవుట్. మీరు డాష్ బోర్డ్ క్రియేట్ చేస్తే ఎలా కనపడుతుందో థీమ్ అండ్ లేఅవుట్ ఎండ్లో ఉంటుంది. కనబడకపోతే తగ్గించుకోండి, సైజ్ తగ్గించుకోండి, జూమ్ ఇన్ చేసి జూమ్ అవుట్ జూమ్ ఇన్ చేసుకొని సో యూజువల్గా ఎడ్జ్ ఈజ్ ప్రిఫరబుల్ లేదా కాన్స్టలేషన్. ఇదైతే బ్లాక్ ఎండ్ వస్తుంది, బ్యాక్గ్రౌండ్ అంతా బ్లాక్లో ఉంటుంది. లేదా ఇది తీసుకుందాం, సెలెక్ట్ చేసుకొని లేఅవుట్లోకి వెళ్ళి ఇక్కడ రెండు వస్తాయి, ఫ్రీ ఫాము, రెస్పాన్సివ్. ఇది చాయిస్ అనమాట. లేఅవుట్ మోడ్ ఫ్రీ ఫామ్ తీసుకున్నాను నేను. కిందకు మూవ్ అయిపోతే ఇక్కడ మీకు అది ల్యాండ్స్కేప్ మోడా పోర్ట్రైటా అని వస్తుంది. ప్రిఫరబుల్ పోర్ట్రైట్. దెన్ ఇక్కడ 10px అని ఉంది, 50 ఉంది, నేను 10 పెట్టుకుంటున్నాను. క్లోజ్ చేసి సో థీమ్ అండ్ లేఅవుట్లోకి వెళ్ళి థీమ్, మీకు కావాల్సిన థీమ్ సెలెక్ట్ చేసుకోండి. స్పెసిఫిక్ ఇదే చేసుకోవాలని లేదు, మీ ఇష్టం. దెన్ లేఅవుట్లోకి వెళ్ళి పోర్ట్రైట్ మోడ్ పెట్టుకోండి. దెన్ గ్రిడ్ సెట్టింగ్స్ వచ్చేసి 10 పెట్టుకోండి, ఈజీగా ఉంటుంది మనకి. ఇది మన స్క్రీన్ బట్టి మారిపోతూ ఉంటుంది. నేను ఇక్కడ 10 పెట్టుకున్నాను, మీకు కావాల్సింది మీరు పెట్టుకోండి. లేఅవుట్ కనపడలేదంటే మీరు జూమ్ ఇన్ చేసుకోండి. ఏనండి, ఏదండి మీ ఇష్టం. A4 పోర్ట్రైట్ పెట్టుకోండి, పర్లేదు. నేను స్క్రీన్ పోర్ట్రైట్ పెట్టాను. సో మన విండోస్ పవర్ పాయింట్ కానీ వీటిలో ఉన్నట్టుగానే దీంట్లో కూడా ఆప్షన్స్ ఉంటాయి. ఫైల్ మెనూలో ఫైలు, ఎడిట్, వ్యూ, ఇన్సర్ట్, మల్టిపుల్ ఆప్షన్స్ ఉంటాయి మనకి. ఇక్కడ ఫైల్లోకి వెళ్తే ఆ థీమ్ లేఅవుట్ అక్కడైనా కనిపిస్తుంది మీకు ఇక్కడ థీమ్ లేఅవుట్ కనబడకపోతే ఫైల్లోకి వెళ్ళండి, అక్కడి నుంచి థీమ్ లేఅవుట్ తీసుకోండి. గో టు ద ఫైల్ మెనూ అండ్ సెలెక్ట్ ద థీమ్ లేఅవుట్. Then if you go into insert, you will get multiple options for the plotting options, time chart, vertical bar chart, histograms, lot of things. So today we're going to do two things. I'm not going insert from here, I'm going from add a chart. I'm clicking add a chart, then I'm going to line plot. I'm selecting line plot here. Then here we require to provide x-axis and y-axis. X-axis is our year. So I'm going with setting year here. Instead of month, I'm setting as a year. యాడ్ చార్ట్లోకి వెళ్ళండి, అక్కడ లైన్ అని ఉంటుంది, ఏది తీసుకున్నా పర్లేదు, మారవచ్చు. దెన్ వై యాక్సిస్లోకి వెళ్ళి మ్యాట్రిక్స్ వై యాక్సిస్ అనామలీ. దెన్ కిందకి వెళ్ళిన తర్వాత ఇక్కడ డేట్ రేంజ్ అని ఉంటుంది. ఓకే, ఇక్కడ షార్ట్ అనామలీ దగ్గర ఇయర్ పెట్టండి. సమ్ దగ్గర యావరేజ్ అని పెట్టండి. ఎస్ఎంపి వై యాక్సిస్ మీద ఎనామలీ పెట్టండి. అండ్ దెన్ ఇక్కడ క్లిక్ చేస్తే సైడ్ సమ్మని తీసుకుంటుంది డిఫాల్ట్గా. దాన్ని సెలెక్ట్ చేయండి. ఇక్కడ ఇది సెలెక్ట్ చేస్తే మీకు ఇక్కడ అగ్రిగేషన్ అని వస్తుంది. సమ్మా, యావరేజా, కౌంట్ అని వస్తుంది. యావరేజ్ సెలెక్ట్ చేసుకోండి. సమ్ కానీ కలెక్ట్ చేస్తే ముందు ఎన్ని అక్యుములేట్ అవుతాయి, మనకి క్యుములేటివ్ సమ్ వస్తుంది. ఇదంతా మనం సెటప్లో చేస్తున్నాం. చార్ట్ స్టైల్లో సెటప్లో చేస్తున్నాము. దెన్ మీరు స్టైల్లోకి రండి. విచ్ వన్? మీరు ఫిగర్ని సెలెక్ట్ చేస్తే వస్తుందండి. యాడ్ చార్ట్లోకి వెళ్ళండి. ఫస్ట్ చార్ట్ వచ్చిందా? చార్ట్ వచ్చిన తర్వాత మీకు అక్కడ వచ్చింది కదా చార్ట్ టైప్స్లో ఎక్స్ యాక్సిస్, వై యాక్సిస్ సెట్ చేశారా? ఈ ఫిగర్ వచ్చి ఈ డ్రాయింగ్ వచ్చిందా మీకు అక్కడ? ప్లాటింగ్ రాలేదా? ఓకే, అయితే ఒకసారి మీరు ఇది చూసుకోండి. ఎక్స్ యాక్సిస్ దగ్గర ఏముంది? ఇయర్ ఉందా? నెంబర్ ఉందా పక్కన? డివై ఉందా? ఇయర్ ఉందా? ఇయర్ ఉంది. ఓకే, ఆ తర్వాత కిందకి రండి. మ్యాట్రిక్స్ వై యాక్సిస్ దగ్గర ఎనామలీ పెట్టండి. ఎనామలీ సెలెక్ట్ చేసుకోండి. ఇక్కడ యావరేజ్ వచ్చిందా? సమ్ బదులు యావరేజ్ పెట్టండి. ఇక్కడ సమ్ అని వస్తుంది మీకు మామూలుగా డిఫాల్ట్గా. ఇక్కడ సమ్ అని ఉందా? సమ్ అనామలీ అని ఉందా? మెట్రిక్ వై యాక్సిస్. యాడ్ మెట్రిక్ అక్కర్లేదు. ఉన్న మెట్రిక్నే అక్కడ వేరేది ఉంటే అది రిమూవ్ చేసేసి ఎనామలీ తీసుకోండి. ఆ పక్కన సమ్ అని ఉందా? యావరేజ్ అని ఉందా? ఎనామలీ ముందు సమ్ ఉంటే దాన్ని యావరేజ్కి కనెక్ట్ చేసుకోండి. ఇక్కడ డ్రాప్ డౌన్ తీసుకొని యావరేజ్కి కనెక్ట్ చేస్తే మీకు ఫిగర్ వచ్చేస్తుంది. ఓవర్ 10 minutes. ఓకే, ఎక్కడ అయిపోతుంది? మీరు ఇది చేయాలి కదా. ఇక్కడ యాడ్ ఫిల్ చూసి యాడ్ క్యాలిక్యులేటెడ్ ఫిల్ తీసుకోండి. ఒక వేరియబుల్ ఇచ్చుకోండి, ఏదో ఒకటి డివై ఏదో ఒకటి సంథింగ్. ఇక్కడ ఇందాక నేను ఒక ఫామ్ ఇది పంపించాను చూడండి, వాట్సాప్లో వచ్చింది చూడండి. అంతే, అక్కడ డేటా మారితే ఇది కూడా గ్రాఫ్ కూడా మారిపోతుంది. డాష్ బోర్డ్ లాగా డేటా విజువలైజేషన్ కాదు ఇది ఎందుకు పెట్టుకుంటాం? మీరు మార్చుకున్నారా? ఇది తప్పు, ఇది మీరు నేను ఇచ్చిన డేటా కాదు, ఇది మీరు ఒకసారి చెక్ చేసుకోండి. ఇది నా మనం ఇక్కడ టైం ప్రకారం తీస్తున్నాం బాబు. యాజ్ ఎ ఫంక్షన్ ఆఫ్ టైమ్ వీఆర్ డ్రాయింగ్ ద ఎనామలీ. సో అందుకని ఎక్స్ యాక్సిస్ ఇయర్ ఉంది, వై యాక్సిస్ వచ్చి ఎనామలీ తీసుకున్నాం. తర్వాత ఇప్పుడు మీరు అక్కడ రిఫరెన్స్ లెవెల్ 0 రిఫరెన్స్ లెవెలా లేదా 5 డిగ్రీ పైన ఉండలేదు అనుకున్నప్పుడు అక్కడ మనం ఒక రిఫరెన్స్ లెవెల్ పెట్టుకోవచ్చు అనమాట. స్టైల్లోకి వెళ్ళి ఇక్కడ యాడ్ రిఫరెన్స్ లైన్, యాడ్ రిఫరెన్స్ బ్యాండ్ అని ఉంటుంది. సో అవి యాడ్ చేశారంటే మీకు కనబడుతుంది. ఇది వచ్చేసి రివర్స్ వై యాక్సిస్ డైరెక్షన్, ఇది కూడా మార్చుకోవచ్చు ఇక్కడ మీరు. కావట్లేదా? మీరు సెలెక్ట్ చేసుకుంటే కరెక్ట్గా వస్తుంది. మీరు అసెండింగ్, ఓకే, మీరు అసెండింగ్ పెట్టుకోండి. ఇక్కడ మ్యాట్రిక్స్ కింద డేట్ ఇక్కడ ఉంది చూడండి. ఇక్కడ షార్ట్లోకి వెళ్ళి అక్కడ అసెండింగ్లో పెట్టండి, మీకు వస్తుంది. అగైన్ అక్కడ యావరేజ్ అని ఉందో సమ్ ఉందో చూసుకోండి. యావరేజ్ ఇదైపోతే నేను ఇంకొకటి చూపించాలి. ఓకే, ఇది మీరు ఎక్స్ప్లోర్ చేయండి. తర్వాత రెండో దానికి వెళ్ళండి. యాడ్ చార్ట్లోకి వెళ్ళి, యాడ్ చార్ట్లోకి వెళ్తే అక్కడ మీకు స్క్రోల్ చేసుకుంటా ఉంటే డిఫరెంట్ చార్ట్స్ ఉంటాయి. పివోట్ టేబుల్ అని ఉంటుంది చూడండి, పివోట్ టేబుల్. ఇక్కడ మనం ప్లాట్ చేసింది ఏంటంటే టైం సిరీస్ ప్లాట్ చేసాము. పివోట్ టేబుల్లో నేనేంటంటే నాకు మంత్ వైజ్ ఎలా ఉంది, ఇయర్ వైజ్ ఎలా ఉందో నేను చూసుకోవాలనుకున్నప్పుడు పివోట్ టేబుల్ తీసుకుంటే దీంట్లో 3 రకాలు ఉన్నాయి. ఇద్దరు ఫస్ట్ పివోట్ టేబుల్ అని తీసుకోవచ్చు, లేదా బెటర్ ఏంటంటే పివోట్ టేబుల్ విత్ హీట్ మ్యాప్ తీసుకోండి. తీసుకున్న తర్వాత మీరు ఇక్కడ కింద రో డైమెన్షన్ దగ్గరికి వెళ్ళి అక్కడ డివై సెలెక్ట్ చేసుకోండి. సారీ, రో డైమెన్షన్కి వెళ్ళి మంత్ సెలెక్ట్ చేసుకోండి. కాలం డైమెన్షన్లో ఇయర్ సెలెక్ట్ చేసుకోండి. ఓకే, ఇట్స్ ఓవర్ నౌ. సో నెక్స్ట్ క్లాస్ ఒకటి ఉంది, దాంట్లో మిగతా డిస్కస్ చేద్దాంలే. మీరు సేవ్ చేసేసుకోండి, మళ్ళీ రేపు నెక్స్ట్ వచ్చినప్పుడు నేను చెప్తాను. రేపు కానీ ఎల్లుండి కానీ ఉంది. ఓకే, ఓకే, ఇది ఎవరికి ఇచ్చేయండి, ఇదేదో తీసుకురా. ఆంధ్ర యూనివర్సిటీ నుంచా? ఓకే, 96. నేను రాజమండ్రిలో చదివాను, ఎంఎస్సి రాజమండ్రి ఆర్ట్స్ కాలేజ్. నాది వచ్చేసి 2002, 2000. ఎక్కడ? ఇది 1 వీక్ మీకు ప్రోగ్రాము? 5 days. బాగా నేర్పిస్తున్నారు, కొత్తగా ఉంది. నేను సిలబస్ చూశాను. ఓకే, సార్ కొద్దిగా టైం మీరు